Good morning. Good morning. Yes, I'd like to start IIASA 50th Anniversary Conference. I am Jae-yong Yoon from Seoul National University. I will be moderator in opening sessions. As part of the 50th anniversary celebrations of International Institute for Applied System Analysis, which is IIASA, Korean IIASA Committee and IIASA now is jointly organizing this conference in Seoul in order to highlight and consolidate ongoing collaborations. This conference will welcome including IIASA alumni to explore how system analysis can provide sustainable solutions to global, regional, and local challenge. As in opening sessions, we have a greeting from National Research Foundations of Korea is Professor Lee Gang-bok, Dr. Lee Gang-bok, who is President, National Research Foundations of Korea. Please welcome to his greeting.
Korean way, we start with the power like this. Yeah, good morning. I'm K. Billy from NRF. Dr. Albert van Jasbelt, the Director General of the International Institute for Applied Systems Analysis, and Professor Jo Myung-rae, the former Minister of Environment, Professor Moon-gi-ju, the chair of the IIASA Korea Committee, and all the distinct guests from, and I heard that there is a few attendees from overseas, so we appreciate their attendance. And also it's my great pleasure to congratulate IIASA in person for its 50th anniversary. Over the last 50 years, IIASA has made many remarkable achievements in the global research community by introducing and advancing system analysis methodologies to cope with the global and regional challenges. And I heard a little bit more about IIASA this morning, and I found that I'm not very sure, but I think they deserve Nobel Peace Prize. Moreover, IIASA has played an important role as a research hub where international talents from different fields can collaborate and develop their research into practical scientific advice for policymakers. Since 2007, the National Research Foundation of Korea, NRF, as a national member organization, has established a close partnership with IIASA and has been implementing various initiatives not only in joint research but also research exchanges such as the Young Scientist Summer Programs and postdoctoral program for young researchers. In particular, the NRF has recently funded 2 joint research projects in line with IIASA's strategic initiatives, which are expanding collaborative ground for the 2 organizations more than ever. I believe today's conference will be an excellent occasion for us to look back at our achievements and seek future paths for more active collaborations. As we all know, we are living in a time of environment changes, and these problems are starting to affect our daily lives. Air pollution, water, energy, climate changes, and demographic issues are some of the top priorities that should be addressed collectively based on international collaborations. That's why we are here today. This event will be an opportunity for us to precisely diagnose the problems we are facing and figure out sustainable solutions from system analysis perspectives. To the young researchers, I hope what you hear and experience today will be an inspiration to think about the responsibility of researchers, that our research should not end as mere research itself, but meet the social needs of the people. Lastly, I hope this conference will strengthen our sustainable research collaboration to solve global and regional challenges. This is about time to finish my speech, but I'd like to add one more statement, but it's not in there. Yes, I have to think, but from what I heard this morning, now, as you know, there is some kind of competition between two big countries, China and USA. So here is Europe, here is Korea. So maybe, not maybe, the IIASA has done a lot for peace, but I believe it can do a lot more than before for the peace of the world. So we hope we can all participate for the better future for researchers, for the whole generations to come. So once again, I would like to congratulate IIASA on your 50th anniversary and hope you to enjoy your stay in Korea. Thank you very much.
Thank you very much. Warm greeting from Dr. Lee. I'd like to give you a little more explanations today's conference. This conference will take place in person and online. And we will consider several issues, environmental problem in the Mid-Latitude region, MLR, and global challenges in water, food, energy nexus on the climate challenge and carbon neutrality, and pollutions and well-being on the carbon neutralizations. Before introducing keynote speech, important thing not to missing, this conference hosted by IIASA, Luxembourg, and NRF is Seoul, Korea, and organized Oh-Jung Resilience Institute at Korea University and Social Eco-Tech Institute and Kongung University, and many other organizations who are supported. Now, I'd like to introduce keynote speech from IIASA Director General, who is Dr. Albert van Janspelt, Director General, IIASA. Please welcome Albert, Dr. Albert.
I guess I should follow suit.
Thank you so much for this wonderful opportunity to speak to you all today and for your wonderful hospitality. We really appreciate that we can be here with all of you. From my side, Professor Lee, former Minister Cho, Professor Yoon, Professor Moon, thank you so much for hosting us from IIASA at this wonderful venue in this wonderful city. We really appreciate our time with you. I'm going to tell you a little bit about IIASA, if I may. This is our headquarters in Luxembourg. It's the castle that you will hopefully come and visit us at soon and spend a bit of time with us at these wonderful facilities provided by the Austrian government for IIASA. So I explained to Professor Lee earlier, IIASA was created in the 1970s as a child of science diplomacy to create scientific dialogue and collaboration in areas of peaceful research between countries that were in the midst of the Cold War at that point in time. And IIASA will continue to play this kind of role in the world, hopefully moving forward. We will illustrate that by virtue of some of the projects that we're going to demonstrate to you today as well. This is the IIASA membership at the moment from around the world. We're very proud to introduce at the bottom end the membership from Sub-Saharan Africa, which is a regional membership, the first one of that kind in the IIASA family, that brings together 17 countries with a single representation on our council to represent a very important part of the global research community that we feel we need to engage with as an institution. So IIASA's work focuses on complex matters. And this is the kind of challenge that most policymakers, and I would imagine Minister Cho would appreciate this kind of figure in front of him. When you deal with environmental matters, social matters, financial matters, this is the complexity of the policy-making landscape that you have to tackle and unravel and come up with sensible solutions that will hopefully drive the system in the right direction. Now, we at IIASA have, oops, sorry, I need to go back. There we go. Have developed over many years a whole range of models that we use to explore the complexity of that environment that I just showed you. We have models that range from an energy model to a pollution model to a water quality model, agricultural and bioenergy and forestry, etc. You can read the whole list in front of you. But the strength of the IIASA models is the fact that, first of all, that they are coupled to usually population models at the same time, so we understand exactly what the consequences of the populations are, but also tied to the economy, so that we get an understanding of the financial consequences of the decisions that we propose. But at the same time, IIASA is also increasing our capabilities to make sure that our models actually talk to each other, in other words, so that the energy model can talk to the land use model, can talk to the economic model at the same time, and to get a understanding of the complexity of the landscape that we're trying to work with, and to come up with scenarios and simulations that can be used for future planning, that can be explored together with our stakeholders at IIASA, and we can then hopefully aid the decision-making process as a consequence. IIASA has recently launched this new research strategy on the left-hand side, and that resulted in a reconfiguration of our research programs at the institution into 6 major programs. You can see them in front of you. A program that focuses on advancing systems analysis, which is our core business. It's our methods group, if you like, at IIASA. Biodiversity and natural resources, energy, climate and environment, population and just societies, the new program, Economic Frontiers, and then a strategic initiatives program that was referred to a little bit earlier, where we engage with our member organizations around key areas of work that we collectively feel needs to be developed in the foreseeable future. So this is the configuration that we have at the moment. IIASA is very proud of our research. Should I use this one rather? Okay. I hope, is that clearer? Okay, thank you very much. IIASA is very proud of its research contributions and history. As you can see, we produce in the highest publications. This is about 10% of our annual output that we produce in these high-impact journals. And our researchers have a solid reputation for continuously contributing to the best of science that comes out of the area of work that we're involved with. We house, amongst our researchers, some of the best in the world. These 12 people represent, or all on the Clarivet Analytics top 1% cited researchers across the globe in their respective disciplines. And so people that engage and work with us can engage with these people directly, and some of them, of course, in the audience today. And the whole idea is that when people come to IIASA, they know that they're going to encounter some of the best people in the world in their particular areas of expertise. It's really important. Our scientific excellence and reputation for the institution remains at the forefront of what we try and do as far as our work is concerned. Some of these people, of course, are even recognized in 3 or more fields across the IIASA staff. Sorry, there's a bit of a delay. I don't know which direction I'm supposed to point this thing. Oh, it's over there, is it? It's getting stuck. Is it gone? Okay. Have we jumped something now? I guess we have. Let me just go back. No, we didn't. Okay, thank you. All right. I'm going to just demonstrate for you some of the modeling work that we've been doing and how it actually works. This is our community water model, one of the most recent developments at IIASA. And I don't want to go into the details here, but this is a particular study that's focused on Malaysia, but it just emphasizes a point that's come out of our work that we've done with our community water model around the world, is that under conditions of climate stress, which we now are going into, and climate change, which we are going to have to tackle in the foreseeable future, the one variable that's popped up repeatedly is that the issue of seasonal water availability is going to become a real issue around the world, in many countries around the world, not just in Malaysia. So this is something to watch out for and to try and focus on. Although countries may have a lot of water, at some times of the year, they may not have it throughout the year, and that's going to cause significant differences and problems for many communities around the world. We've also recently gone through the COVID-19 pandemic, and we're still trying to get rid of the consequences of that. And of course, all of you would have experienced how societies have changed as a consequence of COVID. That what's happened in areas of transport, areas of energy utilization, and areas of housing, etc. But I think what we try to do in this particular study is to just demonstrate the importance of governments and other decision makers to think about the way that we recover from COVID-19 as an example to take forward. Because not only is it a crisis that we have to recover from, but it's also an opportunity for us to rethink our society and the way our societies work. We could, for instance, in the worst case scenario, just simply, this is where we were before COVID, we could simply return to a pre-COVID situation. In other words, continue to live the way we did before COVID, and the consequences would be society has not shifted or moved at all in this space. But we could have an increasing self-reliance being brought into our systems. In other words, that allows us to move in these particular sectors in terms from where we were to some degree, and that means society could function slightly differently and actually be more efficient and more effective moving forward. But if we're really concerned about the environmental consequences of the way that societies live, there are many things we can do in terms of smart use and really implementing a green push that could significantly change the way that these sectors function, that could result in a recovery from a crisis like COVID and give you an outcome that is fundamentally different from the way we lived before COVID. So this kind of critical thinking is really important, and I think it's important that we at IIASA, we try and make our contribution as far as understanding the consequences of recoveries from crises and use them to our benefit as best as we possibly can, as an opportunity. This is just another demonstration of the power of the models that we use at IIASA. This is a biodiversity-related issue. In other words, we took some of the global targets that have been bandied about using 30% of land for conservation purposes, and what we're trying to demonstrate here, if you select the land that you use for conservation purposes wisely, the chances are you can actually reap multiple benefits from the allocation of that land to conservation in particular. So by selecting strategic land around the world for 30%, we can also not only safeguard 70% of the plant and animal species that we have on our list, but at the same time you can also conserve more than 60% of the below ground vulnerable carbon and 68% of all clean water that's available. So by using this idea of spatial congruence, you can come up with the solutions that give you multiple benefits in our analysis. This is really important for taking those kinds of conversations forward even at a national level. This is just to demonstrate, first of all, that clean air is an issue in many countries in the world, and people have been paying a lot of attention to it. This figure just demonstrates that there are measures that have been implemented by national governments that may have made a significant difference in the areas of pollution exposure for populations in different parts of the world. There are also recent legislative interventions that people have put in place that are making a small marginal contribution, as you can see in those spaces. But there's also huge further potential for bringing on board new ways of dealing with air pollution that can significantly shift the current levels of air pollution to the kind of levels that you would expect, in other words, that are sort of dependent or aligned with the international standards in this regard. So it's really important to understand that, yes, we've made progress in some spaces, but there's a lot of room for improvement that we could bring to the table to make sure that our populations are healthier and can actually live a long and fruitful life. This just demonstrates that for a number of countries around the world, to just show to you that by simply aligning ourselves with the objectives of the 1.5 degree Paris Agreement in terms of climate mitigation, we can actually precipitate a lot of additional benefits. These are benefits that are precipitated in terms of number of deaths avoided in different parts of the world, simply by making sure that we're compliant with the 1.5 degrees Celsius requirements. So deaths avoided per 100,000 of the population, and it just demonstrates to you what the consequences of a healthier environment can be for total population health at the end of the day as well. This, of course, is an example straight from Korea. Our population unit has been spending a lot of time analyzing many countries around the world, but this just demonstrates to you the consequences of your own policies in Korea in terms of your focus on education and what a difference it has made to your population projections from the 1970s to the 1990s to 2010, and what we foresee for 2030 is that, first of all, the education profile of your country has dramatically shifted and strengthened, and you will have experienced that yourself as well. If only every other country in the world were as focused on education as a tool to change the demographics of their population and their competitiveness in the long run, we'd all be in a very different space in terms of dealing with progressive societies. And I think this just emphasizes that particular point, that people are always concerned about what are the consequences, or the economic consequences of an aging population where you have more older people than young people in the workforce. But what our analysis also demonstrates to you is that it's not just the number of people in your workforce that's important, it's the quality of your workforce that's going to determine whether you remain competitive into the future or not. We're going to hear a little bit more about this in the next session, so I'm not going to talk much about this, but I just want to emphasize that collaborations between IIASA and Korean scientists have defined this combined mid-latitude ecotone region as an area of focus, and we're going to listen to that in the next session, so I'm not going to expand it, but we're really proud of the fact that this just demonstrates that there's ongoing collaborations between Korea and IIASA that is of importance. This is a particular analysis that looks at trade-offs, trying to understand the consequences in a particular basin. This is the Indus Valley Basin that's shared between Pakistan and India, and looked at the consequences for water use, energy security, and land use, and the risks associated with different climate regimes into the future for those applications. So whether you step up from 1.5 degrees to 2 degrees to 3 degrees, the risks across the basin actually shift around, not only in terms of their severity, but also in terms of their spatial configuration. And so one has to think very clearly about how you're going to plan for the optimal use of the resources that you want in that space. So in other words, how much of the land are you going to assign to particular agricultural activities or energy production, or how much of your water resources go towards energy production or agricultural use, etc. So this is the kind of integrated assessment that we at IIASA specialize in, so that we can come up with solutions that gives you a more holistic picture of the consequences of policy making. And what we try and prevent here is to make sure that as a consequence of making decisions in a single dimension, so we're just looking at water use, for instance, you'd come up with a very different answer from looking at an integrated assessment approach from this. And so we're trying to make sure that we try and avoid, to the best of our ability, any unintended consequences that flow from siloed decision-making in the environmental field. So just to summarize, this is the kind of integrated approach that we at IIASA try and use. We have at our disposal well-established models that we use and apply. From them, we can develop a comprehensive set of nexus indicators, things that we look at moving forward. We can inject a degree of uncertainty, in other words, the surety associated with those modeling assessments and outcomes, and at the same time, we can make sure that we can do a spatially explicit analysis and come up with potential answers. We, of course, never do this in isolation. We do this in collaboration with the researchers and people across the world and make sure that we deliver answers that are compatible with their particular wishes and their own particular demands as best as we possibly can. So with that, sir, I'll finish the presentation right here. Thank you very much for your time.
Thank you very much. It's Dr. Albert, very nice introductions about what IIASA is doing. It's certainly, its world is very complicated. We need system analysis. I recognized IIASA is treasure house of system analysis, will be is future champion of science diplomacy. Next keynote speech, I'd like to introduce keynote speech from Korean side is Professor Jo Myung-rae. He is distinguished professor, carbon neutrality study. Very interesting, right? Dankook University. He also he was 18th Minister of Environment, Republic of Korea. He did great contributions to its sustainable development, our society. Please welcome his Professor Jo.
네, 안녕하세요. Good morning, ladies and gentlemen. As introduced, I am Myung-rae Jo, distinguished professor at the Dankook University and the former Minister of Environment for the Republic of Korea. It is a great honor for me to be keynote speaker at this outstanding conference. Thank you to the organizers of the conference for the kindly inviting me. The core idea of my speech is how to carbon neutrality can be put into practice to achieve the immediate goal of curbing 1.5 degrees Celsius rise from pre-industrial levels. Korea adopted 2050 carbon neutrality in 2020 after my ministerial level preparations against prevailing negative opinions on the possibility of carbon neutrality. This made me dedicate my remaining life to being carbon neutral in Korea. I strive to find a path toward long-term carbon neutrality with the heuristic concept of a green transformation. What the hell does carbon neutrality mean? Put simply, carbon neutrality is expressed on equation carbon emission by a source minus removals by sink equals zero, net zero. This is very simple and a straightforward, self-explanatory signifier. To reach, according to this equation, to reach a net zero, either dramatically increase the amount of reduction or maximize the amount of carbon uptake or removal. However, solving this equation in complex realities is by no means an easy task. Carbon neutrality will face enormous cost and social conflict related to the reshuffling of high carbon economies and social relationships. In the insight of environment economics, the roots of these carbon neutrality problems is tragedy of commons or free riders problem. We will come back to this issue in a little while. How can we overcome this hurdle and be carbon neutral? I believe that the answer depends on interpreting why carbon neutrality is needed, what carbon neutrality is for, how carbon neutrality is implemented, and what underpins the long-term implementation of carbon neutrality. To navigate to the path toward carbon neutrality, I would like to briefly answer these questions. The first, how to cope with the climate crisis in Anthropocene. Carbon neutrality does not simply mean radically reducing greenhouse gases, it's making global warming a main indicator of climate change. With the advent of the Anthropocene, which is new geographical era after the Holocene, we call the 충격세. Climate change is no longer a problem of global warming. This is my belief. It is simultaneous occurrence of geological equilibrium in climate systems which transcend so-called planetary boundaries. Therefore, climate change is not environment problem. It is problem of the Earth system in nature. New policy actions on climate change must address new norms such as halting 1.5 degrees Celsius rise, changing socio-ecological systems, planetary democracy, the survival of human and non-human beings, the integration of humans and nature. Therefore, I'd like to invent new term integrative or inclusive carbon neutrality. The Intergovernmental Panel on Climate Change has included the term Anthropocene, we call the IIASA, in 2018 1.5 degree special report and has declared carbon net zero, carbon neutrality to prevent man-made greenhouse gases from entering the global climate system. This may be latest or last policy card derived from the evolution of climate change policy at the global level. The technical solution to carbon neutrality is to reduce carbon emission in the case of Korea by 80 to 90% from the current levels by 2050. This presupposes virtually decarbonization of existing social economics that depend on long-term consumption of high carbon energy. How can we succeed in such radical social economic reform within one generation? This must be done in a way that not only integrates all sectoral carbon reduction efforts, but also combines carbon reduction and ecological restoration within the framework of green transformation. It should be understood that the carbon neutrality aims simply not to reduce carbon emission, but more fundamentally to end the climate crisis of the Earth system or restore the Earth's climate resilience. Carbon neutrality is a way to or means to do this. A carbon neutrality policy should therefore function to promote decarbonization in order to restore global ecological resilience. This is why the EU's 2050 carbon neutrality is supported by Green Deal to integrate carbon emission reduction and ecological recovery into one policy package worth €1 trillion. This possibility has to do with how carbon neutrality is structured into decarbonization. Carbon neutrality on this 30-year transition trajectory requires a shift from drastic emission reductions to green transformation of societies, which are compatible with climate resilience through the carbonization of the economy. This means that carbon neutrality itself a way or means for society's green transformation. Green transformation here, an extended frame of carbon neutrality, which combines measures to reduce carbon emissions and ecological restoration within the scope of carbon neutrality policies. In relation to ecological restoration, various nature-based solutions proposed so far are known to contribute to eliminating 1/3 or 1/4 of global carbon emissions, which is 10 gigatons of carbon dioxide equivalent per year. Remember that carbon neutrality equation consists of two variables: carbon reduction by humans and carbon removals by nature. You can also get close to net zero by maximizing second variable, carbon uptake or removal. As in the equation, carbon emission reduction and ecological recovery in policy have a complementary effect, promoting carbon neutrality to green transformation of society through decarbonization. Green transformation on an extension process of carbon neutrality must internalize the enormous cost of transformation and conflict resolutions into socio-economic systems in a country. Here, costs include not only monetary value indicated in market price, but also social obligations of individual and collective emitters for voluntary emission reductions. Broadly speaking, these costs are social expenditures for reforming the carbon emission system or reforming social ecological systems, which rely on high carbon energy. So, system change approach to carbon neutrality is essential. Green transformation should be promoted in the form of gradual conversion of societies' carbon emission systems into integrated carbon neutral system. This is, in fact, a social process of decarbonization. The biggest challenge here is societies willing to pay. The cost for carbon neutrality or green transformation is the cost of externalities contributing to the tragedy of commons in economic terms. In other words, free ride problems inherent in provision of public goods are more likely to be reported in carbon neutrality or green transformation. How can we make society as a whole willing to bear the cost? This may be possible when we trust that transformation costs such as carbon-free technological development and carbon removals are being made to generate benefit of transformation in the future through investment mechanisms. Internalizing cost, including obligation or liability cost, into socio-ecological system of society should be designed with the premise of returning benefit through green transformation. The cost for green transformation to address climate crisis is essentially cost of an investment, which can grow if not paid or invested in timely manner. The cost to prevent global temperature from rising by 1.5 degrees Celsius above pre-industrial levels would be around 4.3% of global GDP. However, if you do not pay or do not invest, it is estimated that the cost of a rise 2 degrees Celsius or more would be 3 or 4 times the above investment cost. According to one study, the 5 largest carbon-emitting companies in Korea, such as POSCO and Hyundai Motor, will lose 30% of their annual sales by 2030 if they do not proactively respond to how global regulation on carbon neutrality. In order for Korea to achieve 2050 carbon neutrality, so-called carbon productivity, an index of separating carbon growth and carbon emissions, needs to be improved by 10 to 14 times from current level. This is equivalent to the growth of labor productivity achieved over 120 years of industrial revolution in the US. Green transformation should be organized and carried out in stages through a combination of various policy measures for carbon emission reduction and ecological restoration. At the early stage, for instance, during 2020s, carbon neutrality policies should focus on 2 areas. The first, avoiding the increased cost of climate-related risks through sophisticated regulation mechanism. And the second, government investment to reduce various uncertainties, like policy uncertainty, technological uncertainty, market uncertainty, all associated to green transformation. At the middle stage, for instance, during 2030s, policies should be concentrated on 3 areas. First, internalization of various climate-related costs by means of carbon prices, carbon taxes, emission reduction duties, etc. Second, establishing sectoral decarbonization regime or decarbonization of emission systems across all sectors. And third, institutionalization of balance or trade-off between carbon reduction cost and ecological recovery credit. At the final stage, for instance, during 2040s, policy should target 2 areas. First, maintaining carbon neutral ecosystem for society, such as new carbon-free business and lifestyle. And the second, establishing climate-resilient social norms and institutions, such as civil right to carbon neutrality and green government systems. Finally, I'd like to talk a little more about democracy for green transformation. Green transformation is achieved through the organization of a social relationship based on high carbon energy, which inevitably entails various social conflict and political contestation among stakeholders. Conflict and disputes arise around the unequal distribution of cost and benefit related to green transformation. In the Framework Act on Carbon Neutrality and Green Growth, this problem must be prevented and addressed in accordance with the principle of climate justice and just transition. However, securing justice in the societal change for carbon neutrality depends on how policies and institutions for carbon neutrality are democratically formulated and work. Carbon neutrality would not work without strong social political consensus and support and participation from all lengths and groups affected by green transformation. Particularly, the voice of new advocates of carbon neutrality, who are mostly minority in our society, should be well or relatively better represented in policy-making processes conducive to high carbon vested interest. As seen in the country of high environment policy performance, such as Nordic countries, the institutionalization of so-called eco-democracy is prerequisite for democratic organization and implementation of carbon neutrality as green transformation. This is primary matter of a political culture. How can we foster such a political culture for long-term carbon neutrality in Korea? I reserve the answer to this question for our homework on how to make carbon neutrality for all. I must end here. Thank you so much for kindly listening. Thank you.
Professor Zhou, thank you for very moving and experienced keynote speech. Green transformation and carbon neutrality is kind of start of new civilizations. Monitoring of greenhouse gases, and without monitoring, no understanding. No analytical analysis, no policy. While Professor Zhou was in administration job, he did Korean government announced carbon neutrality and announced upgrading of NDC, 40% of reduction of greenhouse gases. His speech is well demonstrated how analytical analysis and understanding is transformed into its national policy of carbon neutrality. Okay, now we have video presentations on IIASA Korea collaborations. Are you okay? Please. It's 2 minutes. Okay, did you enjoy? Now we are ends of our opening sessions. Yes, next is we're gonna have a group photo. Please come to the front to take a picture together.
Good morning. I think we are ready to start the session. And I'm Sonam Wang. I'll be moderating session 1. I'm currently working as a research professor at Korea University. Professionally, I'm a conservation biologist, vis-a-vis environmental policy person. Currently, I'm working on human-nature interface, especially in the third pole region, where water, food, energy is already stressed. So, distinguished speakers, panelists, ladies and gentlemen, it is with great pleasure that I welcome the opportunity to moderate this very important session on water, food, energy, and ecosystem nexus. Every one of us is aware of their growing significance. By the way of this moderation, I would like to share a quick thought. Ever since I attended college, the whole world has been talking about water security, food security, energy security. Now I'm almost 52 years old, and we are still talking about water security, food security, energy security. Where did we go wrong? At the crossroads of 21st century, we are saying, the World Bank is saying, the UNDP is saying, the research reports saying that we will be short of 70% water, 70% food, and 50% more energy by 2050. These overwhelming challenges necessitates a lot of resources, information technology, modeling, as well as efforts from our side, from government, how we can change our lifestyle to better our world. At Ojeri Korea University, we reviewed water, food, energy nexus in Mid-Latitude region. Our study indicates that there are very few studies that have actually tackled water, food, energy, and ecosystems as a nexus. Most of them are in silos. So our recommendation is that the scientific community, along with other stakeholders, put a lot of effort in actually looking at the interdependence of these nexuses to gather all the elements. So it's great from that perspective that IIASA 50th Anniversary Conference has prioritized expert discourse on life-sustaining nexus. I wish this event every success and remain excited about the prospects of future collaborations. With this, I would like to welcome our first speaker, Professor Woo Kyung Lee, who is the director of Ojung Resilience Institute and a professor at Korea University, to give his presentation.
Thank you very much introducing our session and myself. But I'm very embarrassed because the time is already over. I can do it, but I tried to sketch my presentation. As you know, in the past, Korea was called the land of morning calm, 루이케 morning lunch, in the perspective of European people. But I think nowadays, Korea is no more than morning calm country, but land of whole day dynamics, especially for young people. However, Korea is still considered as a far eastern countries for European people. There exists still special distance and also differences in time and also interest between Europe and Korea. To narrow those differences, I believe Mid-Latitude region can be a bridge between Europe and Korea. In other words, Mid-Latitude region can be a commonly interested area where space and time of both countries, both Europe and Korea, can meet in this area. And then what and how can you collaborate and work together or meet in the Mid-Latitude region? Mid-Latitude region is characterized as arid and semi-arid climate condition and high proportion of dry land with low precipitation. In addition to dry condition, Mid-Latitude region is still experiencing water shortage due to climate and environmental change and economic development, affecting more than food, water, or almost half of the global population. Furthermore, Mid-Latitude has a great role in global food supply system. The problems in Mid-Latitude is not only remain in this region, but matters globally. Actually, both Europe and Korea already occupy technologies to deal with these issues. In the case of Korea University, we have strong academic performances in those 6 approaches: remote sensing, GIS, spatial temporal analysis, modeling, AI such as deep learning, and big data. I believe our promising young scientists in Korea can achieve great performances in the Mid-Latitude region. Just in my lab, we analyze the future distribution of tree species working together with IIASA for G4M model, the other models, and focusing on Korea, distribution of temperate and boreal forest was decreased and disappeared, even worse in alpine and boreal tree species as European countries. This can also lead to loss of biodiversity in South Korea. Dr. Yu Young-chae, graduate from Korea University, carried out this theme in 2019 as IIASA YSSP. Expand our spatial boundary to Korean Peninsula, it is obvious that climate change and human activities worsen land degradation. North Korea is a kind of example for land degradation. We found that land degradation in North Korea leads imbalance of water equilibrium between agricultural demands and ecological supplies from forest ecosystem. The water shortage in degraded land bring about poor crop productivity in North Korea and carbon imbalance in North Korea. With the land management in terms of water, food, energy nexus in terrestrial ecosystem, these problems cannot be solved. In the perspective of land management, we need to think about applying proper restoration planning. For North Korea, we developed stepwise forest restoration plans considering carbon budget as well as ecosystem services, including water, proper water and food and biodiversity supply. Expanding our capacity to Mid-Latitude region, we have also performed disaster risk reduction research. The following 2 studies aim to reduce drought risk in Central Asia as Kazakhstan, Kyrgyzstan, and we have shared our knowledge with the local experts and governmental steps in 2020 before COVID-19. The methods have been improved as our research continues, from using own meteorological data for assessing the risk in broad area to integrating remote sensing data for assessing risk in fine scale spatial scale. And the newly developed models were kept transferring to local people by workshop. As you know, Korea had bare lands after Japanese time and Korean War in 1950. forest and ecosystem were totally destroyed. However, South Korea has experienced very fast economic growth with the successful ecosystem restoration. But North Korea still suffers from land degradation. Based on these Korean experience, land development phase can be classified degradation, restoration, and sustainability considering economic size, forest stock, and forest area. This research was performed by Dr. Song, who has organized this meeting. I thank you, Dr. Song, by this chance. Because Korea has experienced rapid and compressed development, Korea has so-called big data for economic development as well as ecosystem restoration for last 50 years. If we use this kind of data and experience for last 50 years, Korea case can be a good reference to many Mid-Latitude region countries in economic, environment, social, and political sectors. I think these are very strong capacity for global cooperation with the Mid-Latitude region countries for young people, because we live together here, all the people, for doing this kind of compressed economic development, and young people who enjoy this kind of the compressed development. So we can talk together for narrowing the generation gap in Korea. Korea University already performed collaboration with the EU countries from 2017 to 2019. We have worked with a Horizon 2020 consortium called the EOPN with the NOAA, with the European organization as NOAA in Greece and CERCO in Italy. At EOPN, we developed agricultural monitoring system for enhancing food security. From this year to next year, we are now working with another the Horizon 2020 project called Callisto with the European countries to develop agricultural decision-making platform specialized in AI-based analysis. Another KU Europe cooperation is Fairstream with IIASA starting from this year. Fairstream is a food water biodiversity nexus approach where IIASA and Korea University works for seeking the fairness in terms of water resource distribution. Now IIASA is working in Bhima Basin in India and Korea University in Han Basin and Yongsan Basin, South Korea. As mentioned in keynote speech by the Director General, Dr. Sarsfeld. As the final goal is to supply our developed framework in Mid-Latitude region. Fairstream is a pilot cooperation of IIASA and Korea University for fair water resource distribution in Mid-Latitude region. As you mentioned earlier, Korea University has a strength in spatial temporal analysis using AI technique. To share our knowledge, we developed the software and distributed them through online held on the webinar. A triad developed by Mr. Jo Hyun-woo, one of the developed software, it is specialized drought monitoring using AI. Oh, sorry. We cannot see this, so I'm sorry. Oh. How can video slip? Here's the video slip, but not do that. You can do that? No? I'm sorry, Mr. Jo. Later, in the break time, we can record it. Also, one of the key capacity of Korea University is called diagnostic modeling on natural disasters such as flood, landslide, and forest fire. The diagnostic model predicts the disaster by integrating meteorological data with the satellite images and it is especially effective for short-term prediction with the fine spatial scale by reflecting recent changes of land surface environment observed in satellite data. When IIASA system analysis and Korea University's spatial temporal analysis are collaborated together with the young people, food, water, biodiversity nexus research in Mid-Latitude region will get more diverse and broader and effective. Then, how we need to ask this point? What we need to ask at this point? How can you make a bridge between IIASA and Korea University for the collaboration in Mid-Latitude region? For this question, I suggest 3 ideas. First, host of IIASA KU joint research at EGU, European Geoscience Union, which is held every year in Vienna. Second, host of IIASA KU workshop, as we successfully did in May this year. And then IIASA welcomed us very much and very good organized this workshop. By this chance, I thank you very much IIASA staffs and organization. Lastly, the pre-YSS program to offer pre-training program before attending IIASA YSS program. I can daily say you are ready and also still hungry for further collaboration with for the water, food, biodiversity nexus with the young people, with the IIASA together. This is the last slide of my presentation. In our research, there are 2 more presenters by the Andrei Kravsky online here, and Rastislav Skalsky on site, and 5 discussion panels for our the discussion, including Professor Jenny Sajintiev in Kazakhstan and Lijan Gayasta in Nepal. By this chance, I thank you very much for 2 more presenters and 5 discussion panels. Thank you very much, and enjoy your discussion. Thank you very much.
Thank you, Professor Lee, for sharing your vast experience and knowledge on water, food, and energy nexus, and also recommending future collaboration proposals here. Next, I would like to welcome Dr. Rastislav Skalsky, research scholar from IIASA, to do his presentation. You have 10 minutes. Thank you.
Thank you. I'm really happy to be here and present some our results. We have been on EPIC IIASA modeling platform. We have been developing and using for more over than 10 years now, but started with development basically back in 2003 on the project basis where first regional aspects of this system were developed and introduced. As it was already mentioned by Professor Lee, Mid-Latitude region can face serious problems currently, but also in the future, mostly regarding the crop production and food security. This could be soil erosion or expected decline in crop yields, as well as salinity and irrigation water, which might negatively affect food security in a mid-latitude region. It's obvious that up-to-date and accurate quantitative information is much needed to answer these questions, how this could be further developed, and we are sure that with EPIC IIASA, we are ready to answer some of those questions, not only in mid-latitude region, but maybe also more general in a global aspect. EPIC IIASA is a loose coupling of a biophysical process-based EPIC model, which operates on daily basis, uses data on soil topography, daily climate data, and management inputs on field scale, and produces information about crop production, but also about some nutrient and water cycling and upscaled via the concept of via concept of typical field to the grid cell location or any point in the on the earth. We can produce the spatially explicit information and regional predictions and global predictions of dynamic crop development and different environmental impacts. This data could be easily used by higher level integrated models in other sectors like bioenergy sector or land use sector. Oh, sorry. What is EPIC IIASA? Sorry. EPIC IIASA results are organized in a way that for particular location we can provide a range of possible options which are driven by assumptions on gradually changing inputs into the system. It's mostly like nutrients, water use, but also some assumptions on crop management I will show later. And we are producing okay. We can produce multidimensional data, which we call hypercube, and such hypercube is very useful because you can use then optimization algorithms, which could provide some more, or which could provide some viable options which respect the planetary boundaries, as it is shown here on this example where we used land use driven optimization. And we found out in our study that as much as half of current cropland could be released in case we will cultivate crops on the most suitable areas, as well as we don't need to spend more fertilizers and irrigation water, which is quite important. We can only expect that adverse effects of drought and high temperature could be even worsened by the climate change, which we also proven with our other study focused on Europe, which is kind of important part of Europe, mostly Mediterranean, is an important part of Mid-Latitude region, and we found that even such warming like +2 degrees could negatively affect the crop production in these regions. But we also explored the possibility of offsetting this effect via CO2 fertilization effect, which is thought to be one of important advantage of climate change, so to say, because it provides more nutrients to the plants and it helps plants grow a bit faster. But as you can see, it could somehow provide with this orange line, so that the trajectories in many cases are more optimistic, but still a lot of uncertainty remains around this and should be further explored. Soil erosion. Soil erosion is one of the most important soil degradation factors, and it could cause also yield declines. I would like to point out that this particular study was done in collaboration with our YSSP colleague, Tony Carr, in 2018. As you already heard, YSSP program is quite important collaboration platform we got at IIASA, and we invite talented young people to work with us and share their knowledge and work together towards IIASA goals. In this particular case, we truly evaluated EPIC IIASA model and run simulations over the global regions and found out that the soil erosion could be worst in conditions of extreme topography and high rainfalls. You can also see some regions in mid-latitude region in Europe, in Korea, Japan, which could be affected theoretically. We also found that soil erosion might have adverse effect on productivities of maize and wheat when we compared simulations with and without soil erosion. And EPIC IIASA, as a process-based model, it is important, can also provide information about how this could be offset. And we found out that with increased nutrient consumption, it could be the negative effect on the crop productivity might be offset, but for sure it doesn't solve the problem of soil degradation itself, and in the future it would still require more and more fertilizer and keeping soil unhealthy. Soil organic carbon is considered being one of the key elements towards the net zero emission management in agricultural sector. Yet some questions remain: which particular measures could be helpful here, and how we can how they can impact in positive way the accumulation of organic carbon in a soil. We run bottom-up and top-down study using both long-term experiment data and regional EPIC IIASA simulations on example of Czech Republic, from Europe, and found out that with our regional simulations of EPIC IIASA, when compared to long-term experimental data, we basically can bracket the basic developments which were observed on the long-term experiments, like compared to the control without any treatment and different treatments on the field. With the blue bars you can see the EPIC IIASA estimates, and with the points you can see the bottom-up simulations. What is important with most cases, we really can replicate very nicely what's happening on the field with our original simulations, but our simulations are also sensitive to the input data. Without proper input data, we can end up that the soil conditions which are reported for particular site might be off the average regional data which are normally available from the data. With this, I would like to move to more integrated aspect, as it was already mentioned before. EPIC IIASA could provide biophysical and quantitative information which could be fed then to more integrated networks. And this is actually the example of the conceptual network for food, water, and migration nexus, which was proposed for strategic initiatives called this year. Strategic initiatives, as already Albert mentioned, is a scheme of IIASA to bring or to shape IIASA's research more towards the needs of national member organization countries. And with this proposal, we try to suggest the system analysis network for combining crop production, water resources, land availability, food security, land use, human dimension, and policies in integrative and novel system analysis network, which not only could employ the EPIC modeling cluster, but also the expertise from national member organization countries. With this, I basically would like to conclude and just say that with EPIC IIASA we can produce quantitative and well-formalized data which might be then fed to more integrated networks and used for advanced system analysis in different aspects which use basically the food security and crop productivities. there are still some fields unresolved and provide some possible room for collaboration and collaboration efforts, such as non-systemic, from our perspective, non-systemic disturbations, such as climate disasters, forest fires, drought spills, which are not well represented now in our tool. And I think that the next speaker, Andrej Krasovsky, will somehow address this aspect. So thank you.
Thank you for your presentation on agriculture, food, and of course modeling using EPIC. We now have Dr. Andrej Krasovsky online, who is a research scholar with IIASA.
Yes, hello everyone. Can you hear me?
Yes.
Thank you very much for introduction and for invitation to participate in this great event to celebrate 50th anniversary of IIASA. Unfortunately, I didn't manage to come to IIASA in person, to Korea in person, but I'm happy to present our work that we are doing in the Agriculture, Forestry and Ecosystem Services Group, which is headed by Dr. Florian Kraxner. And in this presentation, I would like to talk about forest modeling under climate change and management scenarios. So first of all, I would like to present a scheme of IIASA modeling cluster, which includes a lot of interdisciplinary tools that ideally are connected. And our group is presented in the boxes in the right. So this group is headed, as I said, by Florian Kraxner, and we have a set of models such as BIVEA, EPIC, which was presented by Rusty, but also a global spatially explicit forestry model, GFM, as well as a wildfire climate impacts and adaptation model, FLAM. And our main interaction is with the integrated agricultural and bioenergy model, which is called GLOBIOM. But in the end, this model is also connected with others in IIASA, for example, the well-known message model, which is providing inputs to the IPCC. So today I'm going to talk about these forestry-related models, GFM and FLAM. Here I would like to present the structure of the current forestry model, GFM. We were trying to harmonize it with EPIC model because EPIC is also spatially explicit model as described by Rusty, and it has a lot of biophysical information. So currently we decided to use this opportunity, and we are developing land modeling system where land cover, soil information, weather data, and other parameters are harmonized on the joint grid between GFM, EPIC, and disturbances models, such as FLAM. So this biophysical modeling block shown in green, it contains also other information such as remote sensing data on productivity, forest above ground biomass, land use change, of course, weather data, including historical data and projections. And currently we are working on the forest disturbances. So first model that I developed is wildfire model, FLAM, but also we are going to integrate more disturbances such as windstorms, bark beetles. On the other hand, we are intensively using forest inventory data where it is available. So we obtain information on sample plots, including a variety of tree species, as well as available in the literature or in the project's yield tables. Then by combining this information, we work on a homogeneous grid, and for each pixel we can identify the variety of species, forest area, and we defined particularly site index for each of the locations based on the biophysical information. And by combining it with the growth dynamics, so growth curves calibrated based on either sample plots or yield tables, we are able somehow to model the forest dynamics and then its interaction with disturbances. Another important part is the management block. So this management, as I said, could come, for example, from the GloBiome land use optimization model, but also there could be scenarios defined by policy makers and stakeholders. So the blue block, which is the GFM model, global forestry model, combines all these factors and produces output variables, which are forest productivity, carbon stock, for example, burnt areas in the forest and others. Just to illustrate this approach, I would like to show a case study that was done by a YCSP student, now Dr. Yu-Yong Choi. It was already shortly presented by Professor Lee. So GFM was used to identify optimal habitat location of major tree species that can be used for afforestation in South Korea. And on the left-hand side, you see how various tree species were modeled by the model in terms of their suitability, but of course also productivity was assessed, and in particular this was used in the carbon-focused afforestation scenario for South Korea, which resulted in the plots on the right-hand side, where the locations of the tree species that produces maximum carbon stock were found. And at the later stage, this carbon focused afforestation was also combined with biodiversity focused afforestation, and even some optimal compositions of tree species were found. When we talk about afforestation, it is very important to take into account disturbances and risk. And at IIASA, we are developing a wildfire climate impacts and adaptation model, which is a fire risk model. And I would like shortly to present its structure. So it has 4 main blocks. One is the weather-related or climate block. It takes into account daily weather conditions, a bunch of parameters to calculate fine fuel moisture. This is one conditional probability of ignition. Then, of course, there should be a source of ignition, which is defined by 2 factors. One is the natural ignitions given by lightning strikes. Another one is a more difficult factor, which is human ignition. And currently we are trying to use, in addition to classical factors such as population density, we would like to extend it to more fire-related parameters such as various socioeconomic parameters, as well as impacts of forest management, distance to roads, or even camping sites. And in this part, we are now using machine learning approaches to find interactions and relations of these factors to human fire ignition probability. Another important block is fuel available for burning. In the forest, it is given by dead wood and litter composition, and we call it biomass, but it can be provided either by remote sensing products, by ground data, or by GFM model in our modeling cluster. So once there are favorable conditions for burning, there is ignition probability, and there is enough fuel for burning, and it's bright enough, then there is a risk of fire. And once the fire starts, the model also models the fire spread depending on, first of all, wind speed, weather conditions, but also some landscape information such as elevation, slope, and lakes as potential barriers. Moreover, we model human impacts such as suppression efficiency, how fast the fire can be stopped in a given region, and it's basically one of the know-how of FLAM. It was originally a calibrated parameter that showed quite good fit to the historical data. So the main idea of FLAM is to find the hotspots, the risk zones of fire, and then look also into the future projections, how the expected burnt areas will develop with respect to climate change scenarios. And I'm very happy that this model, it's a global model. Originally, it was calibrated for European countries. Later on, we had several case studies for Indonesia, for Scandinavia, such as Sweden. Currently, we have a project for Russia, but this summer, I had a very good YSSP student, Hyun-Woo Jo, and he was optimizing the FLAM model for South Korea. So this figure shows that forest fires are becoming an issue in South Korea too, in particular with changing climate. And on this figure, you see historical monthly areas burned, and the highest season is usually happening around March. And in particular, in March 2022, there was the biggest forest fire in the history of South Korea. So that was also quite interesting because it was just the start of the YSSP program. And therefore, Hyun-Woo was working hard to find the factors behind these fires and also try to optimize our global model FLAM. I don't go into details, but I think it's really impressive work done by Hyun-Woo, because we were looking at several particular factors that allowed us to improve the fire frequency modeling. First of all, the model was done at high resolution, 1 kilometer resolution, and it used only local data collected by University of Korea and other sources of national statistics. And the main optimization was done for lightning frequency, for additional ignitions in spring related to agricultural burning, such as paddy burning. So we introduced additional factor of ignition in our model. And finally, there was a nice work of improving the soil moisture computation from purely weather-related fuel moisture to more vegetation-related soil moisture. So this feedback between fuel moisture and vegetation was improved. And as a result, you see that the Pearson correlation coefficient for both historical base period and the validation period was considerably improved compared to baseline. Of course, it's a global model. It was able to capture something, but it needed optimization, first of all, related to much higher resolution and to the specifics of model. So you see that the R-square was considerably improved for both periods in the optimized version. And moreover, it is very interesting that before FLAM usually looked at areas burned, but this figure shows that also the fire frequency, which is shown in the red line, was well captured by FLAM in the green line at a monthly scale. And one of the main drivers of this monthly dynamics was still the probability of ignition by soil moisture, which, as I said earlier, is weather dependent. So it shows that still climate change is one of the main drivers. And also our results indicate that it could lead to more severe fires in the future.
Dr. Andre, I'm sorry to interrupt. You have 1 minute.
Yeah, thank you very much. So but coming back to FLAM, it's a global model. We can do global projections on the representative concentration pathways, and our results show that by the end of the century, the burnt areas could double in the scenario RCP.2. This is the illustration of the hotspot mapping at the global scale. by the end of the century for the scenario RCP 8.5. So the red areas are more vulnerable. And using this global scale approach, we can also look at the mid-latitude regions. So we did this analysis. Of course, uncertainty is quite high, but still we can see the principal trends for each of the climate change projections. And as a conclusions, I would like to say that it is very important to parameterize global models at region scale using national statistics and ground data. So I think the collaboration with South Korea is an excellent example for this. It's important to look at the forest disturbances, natural disturbances such as wildfire, but potentially windstorms and bark beetles in the future and the interaction. And I think the strong link between national statistics and wildfire research is important, in particular for wildfire management and emergency planning. So I hope our work on South Korea will result into these policies. And finally, yes, I would like to mention that I supervised already 3 YSSP students from Korea University, and I would say that they have excellent background, very professional, and also fantastic technical skills. And I think we also learn in particular for local applications and model optimizations from this interaction. So I think this program is very important, and everyone contributes from it. Thank you very much.
Thank you, Dr. Andre, for your very interesting presentation. I would like to now request the panelists to come in the front for a panel discussion. We have 5 panel speakers, 2 online. So Professor Rijan Kayasta, who is a glaciologist with Kathmandu University, has requested that he would like to speak first. Due to the extended ceremony in the morning, I would like to request our panel speakers to limit your thoughts to about 3 to 5 minutes each, please. Thank you.
Oh, okay. Thank you, Professor Wang. And first of all, I would like to thank the organizers, especially OGD and IIASA, for inviting me as a panelist. And I think this IIASA's 50th anniversary conference is very useful. And I was thinking after attending this conference in the morning that it was envisaged in 50 years before, but still we are working on this international as this applied systems analysis in different parts of the world. So this institutes how to say, its importance. We can imagine that how important was it in the 50 years before, because it is still important and we are working in these fields. By hearing the keynote speech of the Director General of the IIASA, Dr. Albert, I found that our current efforts also matched very well with what the IIASA is focusing in the field of food, water, energy, as well as ecosystem nexuses in mid-latitude regions. And he mentioned that availability of water in different seasons, in case of this trade-off in industry river basins of climate change at different scenarios. And we are also working in the very similar field in Nepal. Especially in Nepal, we are mainly focusing on 2 topics: assessing water in glaciarized river basins using glacial-hydrological degree day model, which we have developed in our university, and estimate hydropower potential in those river basins, means glacial river basins. And we are planning to use this GTM, what we call in salt, GTM, in all glacier river basins of Nepal and then into other countries of South Asia first and then globally. We are thinking in that way. And after this running the models, what we will have is that how much water is available throughout the year, because nowadays, due to this climate change, snow and ice or the glaciers are shrinking. So we will not have enough water, especially in the dry periods in future. So that is very important to know. And the hydropower developers or hydropower planners should also think accordingly. Otherwise, they will be not in profit states, because in Nepal's climate is changing and temperature is rising with the 0.056 degree centigrade per year, and minimum temperature is also increasing. And our glaciers have also decreased significantly. 24% glacier area has decreased from 1977 to 2010. And within that period, 29% ice reserve in Nepal has reduced. So these also shows that in future, especially in dry periods, we will have acute water shortages in some basins, glaciers, river basins. But in case of this monsoon period, when we have enough water, there will be no problem. But in case of dry periods, especially May, June, April, May, June, there will be a significant problem in future. So that we have to know in advance so that we can plan accordingly. So these are the topics which our Kathmandu University, especially my group, is focusing. And I think this is very much matched with this mid-latitude regions activities as well as IIASA's focused. So with these notes, I would like to thank once again all organizers as well as the participants. Sorry, I have to leave right now for my office. Thank you very much. Namaste.
Thank you, Professor Kayasta. I'd like to now welcome Professor Sangchul Lee from University of Seoul to share his expert thoughts.
Hi everyone, my name is Sangchul Lee. I'm an assistant professor from University of Seoul. My research topics include such as water resources, agro-ecosystem, AI, and climate change. Today, I want to say that I'm very honored to be here with great scientists from different research institutions. Today, I just give you my small thought how to handle issues with respect to water, food, energy in the context of climate change. Climate change is affecting our environment. So many people would be more familiar with the keyword climate change relative to AI and fourth industrial revolution, because people intuitively fear something dangerous caused by climate change. And every day, not every year, you might hear the keyword from news, record-breaking something, record-breaking precipitation, record-breaking temperature. Those keywords are indicator of climate change impact. So as a scientist, how to handle climate change issue is this very difficult question to us. As you know, response to climate change differs temporally and spatially. For example, drought and flooding can simultaneously happen at the global scale. So to address those issues, I think we have to get together. Climate change is a kind of very complex problem. You require experts from climatology, agronomy, hydrology, and other areas. But it's very difficult to make them together in the one place. I think this conference is kind of big momentum towards addressing climate change issue, and this is great opportunity for scientists to exchange our ideas. So my last statement is, let's work together for our future generation.
Thank you, Professor Lee, for very short but very meaningful thoughts. I'd like now to request Dr. John An from Apex Climate Center to share his expert thoughts. 5 minutes.
Thank you, Dr. Wang. I'm John. First of all, thank you very much for having me for this wonderful conference. I'm working at the APEC Climate Center. Basically, I'm working on how to better represent land surface process, basically water, carbon and energy fluxes and stays on land surfaces. As a climate center employee, I'd like to suggest one more key sector in the food, energy, water nexus, which is climate. Before we start to discuss nexus, we better mention climate crisis. IPCC projected even if we meet the 1.5 degrees C goal, heat wave will likely occur 4 times, and heavy rainfall 1.5 times, and droughts 2 times compared to the period of 1850 to 1900. IPCC also showed that climate change has already altered terrestrial water and agricultural production at global scale. Here is another reason is why climate is important. For the sectoral approach, typically we may want to know climate forecasts, because based on the predictions, we projected the crop yield, energy capacity, and water supply and demand from modeling approaches generally. So we should have high quality of climate forecast. This suggests that we need to make efforts to improve climate predictability. And so far we discussed how climate have impacts on those sectors. However, there is an opposite direction too. Many scientists showed a clear evidence human activities in the sector alter climate dynamics. For example, long-term irrigation and huge artificial water body in a dam have substantial influences on regional climate systems. And that's why there have been studies to incorporate human activities into climate models. Hopefully, now you can agree that climate should be added in the nexus. I think it's time to wrap up what we talk about. I'd like to conclude that a better understanding of interdependence between those sectors, as well as the improvement of the predictability of climate models, can provide an efficacious measure for effective and sustainable uses of water resources and energy, and the enhancement of food security, especially for the mid-latitude region we are talking about. Thank you very much. That's all I have.
Thank you, Dr. Jong. I would like to now request Professor Jay Sajin from Kazakhstan to kindly share your thoughts, please.
Oh, thank you very much. I appreciate, Dr. Sanam. Would you allow me to share a couple of slides, several slides actually, so it will be easy, I guess, yeah, for people to understand.
Sure, you have 5 minutes.
Okay, thank you very much. I think it will be enough, yeah. So thank you very much for this opportunity. And I think I will just go straight forward, some ideas, some thoughts, what will be reasonable to expand and how we'll expand cooperation within Middle-Latitude network. And one of the ideas is to connect more and expand practical skills related to the world skills. We discussed about it on the previous meeting, and this is just idea how we may, within this line, expand our cooperation. So the main idea is that in Central Asia, we somehow between East and West, and we're trying to learn from the East and West. So we have big influence from the United States, which is trying to convince us to use big machines, big tools like this one. And we have a lot of, and we had a big influence from Russia. Also, Russia uses big machine, everything huge, and huge energy consumption, huge water consumption, and so on. But we don't have much influence from South Korea, for example, with these small technologies, with hydroponics. Yeah, for example, South Korea is very strong in these technologies and application of high-tech technologies, and so it's like a top world country now in application of hydroponics. So it will be very interesting to learn how to apply this this expertise from Korea and adapt in Central Asia. One of the biggest problems in Central Asia, we have a big problem with water resources, but hydroponics is very efficient with water resources. And one more interesting stuff that President of Korea, I'm impressed that President of Korea support all these activities related to the world skills. In comparison, in Central Asia, none of the presidents support this type of activities. This is incredible. So I thought it will be very interesting to learn how to adapt this expertise, and maybe South Korean president will share his expertise to our Central Asian presidents, how this type of skills will be very important to expand in Central Asia. And he supports a lot these young skilled experts to apply their skills for the practical stuff. In Central Asia, we just support mostly universities, and we are missing this practical stuff. And it will be interesting to expand cooperation with Global Institute for Transferring Skills. We don't have a proper institute, something similar what you have in South Korea. And I hope maybe it will be a good opportunity to learn how this institute works. And it looks like this institute works in developing countries. Maybe it will be very helpful to set up some kind of cooperation, and within Mid-Latitude regional network to set up some kind of chapter related to this institute, Global Institute for Transferring Skills. We may connect, for example, some colleges in Central Asia, and maybe some colleges in Korea could share their expertise in subsoil drip irrigation, hydroponics, and why this technology will be very, very helpful to set up in Central Asia. Generally, energy, electricity, gas are very cheap in Central Asia. And with this complexity that it's very complicated to export all this electricity, oil and gas to European, to other countries, is some kind of locked area. And we have a lot of cheap energy. The cheap energy is very cheap here. So for hydroponics, we need energy, electricity. And if we try to connect to these business activities, it looks like it could be very sustainable. And so this is main idea. And also in this region, also we have a lot of complex water resources in the United States, in California. They have a lot of big issues. It looks like this technology could be expanded within Mid-Latitude regional network to set up some facilities related to South Korean expertise here and some expertise here. So this is the main idea. So thank you very much. Hopefully I managed to speak in 5 minutes. Thank you.
Thank you, Professor Jay. I would like now to welcome Professor Jae Yoon from Seoul National University to kindly share your thoughts.
Okay. Jae Yoon, Seoul National University. I thought I completed my role by serving moderator in opening session. Surprisingly, I found my name in this panel. Then I'd like to give two simple but very meaningful remark on this session. Is water, food, biodiversity. We know it's very closely related, entwined. So the professional with those areas, different background, has to be meet together, working together. However, with some reason, they don't like each other. They don't meet each other. Right? We had to change system and environment to encouraging is that collaborative research. Second one, in this area, research is very much public-oriented. So we need to have a stable support from the public. Then I see is we have excellent academic output, achievement. Then people don't understand what they are doing. What's the implication? So it's professional in this area and organizations. They need to improve or develop some skill. How to communicate with the public with their great academic output and achievement. Thank you very much.
Thank you, Professor Yoon. I think that's walking the academic talk, so which is very important. I'd like to now give the last chance to Dr. Andre, perhaps 2 to 3 minutes. Would you like to say something?
Yes, I just would like to support all these ideas, and I think it shows that we are living in a very complex world, and there are a lot of issues. At the same time, we have a lot of feedbacks, everything is interconnected. So I think that's why there is a need for such discussions, such meetings, to better understand how we can use our tools, and in particular to meet the goals of the society. Thank you very much.
Thank you, Dr. Andre. I would like the discussion to go on, but in the interest of time, maybe we'll take 3 questions from the audience. No question? Come on, there must be some burning question out there. No? Okay, so in that case, I have one question. My question is to Professor Yoon. I'm very impressed by your thoughts about bridging the academic knowledge, actually translating that into action, which I also agree that in many years have been spent in academic research, but often the research actually translates into action where you make a difference in the life of a farmer, for instance. So you have a lot of experience. Would you like to sort of elaborate a little bit on that, how we can achieve that?
How? That's the big questions. Right. Is how many is general public do we have in this conference? Certainly, we do not have any of them, right? So it's forum, academic meeting. We need to encourage general public to participate so that they can express their opinions and concern. So communicate each other to improve understanding, mutual. That's the one thing we need to do that. Second thing is that we professional. I'm professional too in university. Is actually I have no strong motivations to work professional in other area because it's hard to communicate with them, and without meeting them, I can survive myself. Right? It's finding a funding or writing a paper. If I supposed to write a paper with maybe it's 10 personnel with different academic area, I'm not. It will take a long time. Then how can I get better credit, good credit from the academic world without such a small achievement academic output, right? So we need to change the evaluation system in university, and also research institute too. Right? That's my small suggestion.
Thank you for very thought-provoking thoughts. Professor Lee, would you like to say something? Maybe 1 minute? No? How about Skarlowski? Would you like to say something? Okay. So I think that brings us to the end of the session.
May I comment? Just give you a small comments on your question. Sorry, Dr. Sonam.
Sure, Professor Jay, 1 minute, please.
Yeah, I totally agree about this. This is a complex issue. I just have a small, just some ideas what will be reasonable to do in this case. Just a couple of slides. So this is, I think, it's a very important question, how to make more practical all these research activities, what universities are doing for people. I think one of the biggest problems is we are missing proper connection through college system. So I mean, this dual educational system, usually colleges are more connected, community colleges. this level, as they are more connected to the people. And so, I mean, if we review generally this educational system from the school, quite often just many just students, high school students, jump to the universities, and they continue to do something in research activities. And colleges are connected to more to skill activities, and they connected to the more to practical stuff, to the industry. I think this connection should be expanded. When university develops something, some interesting research work on so on, it's necessary to make it user friendly and transfer it to the college and make it as TVET, technical vocational training program. So our president in Kazakhstan, he mentioned about it that it was correct what it was mentioned, that universities concern mostly about publication, grants, and we're missing proper connection to the practical stuff and connection to the industry. If I think we expand this connection, I think it will be very helpful to do all these activities.
Thank you, Professor
So I mean,
Jay.
in many countries, this it's here, I think.
Yeah. We're really short of time. I'm so sorry.
Yeah, just the idea. Yeah, thank you, sir.
I'd like to end the session here. It's very interesting, and I would like to thank the distinguished speakers and the panelists for sharing your deep thoughts on the issues of water, food, energy, and modeling and systems, etc. Thank you, and you have 5 minutes break, and please come back.
Okay, it's time to start session 2. Can you open my presentation? So in very famous Korean word is 빨리 빨리. It's a hurry up square. So we always say that, but we put more works in the small plate. So we always late for the presentation and everything. So, but for this this session, I wanted to do a little more 빨리빨리 manner. So, welcome to the session 2, which is impact of carbon neutral future on pollution and well-being in Northeast Asia. I'm Jung-won Woo, the moderator of this session, and we have 3 IIASA presenters and 4 panelists, 2 from Northeast Asia, 2 from Korea. Okay. Due to the time constraint, I want to start the session right away. So this is my focus of my talk is mostly on the introduction of our collaboration with IIASA and Korean scientists in this scope. Why Northeast Asia? Northeast Asia has 6 countries from China, South Korea, Japan, Mongolia, Russia, and North Korea. In terms of number of countries, it's only have 3% in the world. However, the population, it takes 23%, and GDP is 26%. Moreover, for the CO2 emissions, is more than 40%. And SO2 and NOx, which is air pollutant, is 30 and 28 respectively. So Northeast Asia is small in terms of number of countries, but huge in terms of emissions. Let me start with air pollution. Actually, when we say air pollution, people worrying about concentration only, but concentration itself is the combination of contribution in region and transboundary, as well as the natural thing. And it's also affected by climate, meteorology, and chemistry. However, our basic belief is if we move emissions, then we move concentration. So that's the delta emission to delta concentration belief. So if we wanted to get the lower emission and then get the better concentration, then we have to understand the socio-economical parameters include energy and resources, as well as some natural aspect of the emissions. And we do by applying some control policy and technologies on top of these emissions so that we can control emissions to get the air concentration and reduce health risk. In Korea, we have a huge aircraft field campaign, include 3 aircraft, 2 ships, and more than 300 ground stations and several satellites with the chemical transport model. We end up having a conclusion that our atmosphere is a half and half from domestic and transboundary. And also the fine particles perspective is like more than 80% is secondary formation. So the things around Korea and in the Korea is changing. So this is from Bo et al. 2018. Emissions of China is decreasing. It's with different speed. The SOx is decreasing faster than the VOC. And Korean emission is also decreasing, but it's not as much as in China. The bad news is we have reduced wind speed, which have less dispersion for the concentration, and also we have aging population. So we started to working on emissions inventory with the help of IIASA. We use Gauge Korea, Gauge Asia, and Gauge East Asia and global model to generate Asian emissions inventory from year 2012 up to 2021, and also develop a national version of GAINS in year 2013. So this kind of accomplishment did support regional collaboration called LTP, Long Range Transport, for China, Korea, and Japan. Now is supporting Korea-China Environmental Cooperation, as well as NICAP, which is Northeast Asia Clean Air Partnership of UN ESCAP activity. Together with the scientific research, we can have better understanding, which support better solution from the policy perspective. So in this respect, we actually launched a new project from year 2020, air quality in Northeast Asia, so-called Aquinia. So we work together with some Northeast Asian colleagues, like from China, Tsinghua and Beihang, and Japan, NIAS, and Kyoto, and also IIASA. So I asked some of my colleagues to come to join this session. Okay, for this project, we asked the other countries to bring their own integrated assessment model for their country, and ask IIASA to fill up the other East Asian gap. So here is the joint effort for the region up to stage 1. This is the last year of the stage 1. For stage 2, for next 2 years, we are going to provide information to IIASA's message gauge model to have a future strategy with a uniform platform. So here is just an example of emissions reduction by air quality policy, and another co-control effect from the energy scenario in the future for Korea. We did the same analysis for China and Japan. Okay, and also run the CTM model to get the concentration with transboundary and transboundary plus domestic effort. The health impact in Korea is getting lower in the future if we don't apply the aging effect, but if we apply aging effect, then it will be even increased. Another thing we are doing is net zero scenario for each country like China, Korea, and Japan. For net zero, Korea and Japan will accomplish, planning to at least, to accomplish by year 2050, but China is scheduled for the year 2060. And I will not go over the detail, but the energy mix, the plan, is different by countries. They have some characteristics. Another thing we just launched is a new project from year 2002 to 2026 is Guide Global. So we have a guide model which is a national IAM, but we wanted to expand it to the global and local scale. So local scale gives a very detailed administration unit, whereas the Guide Global has a global coverage. But the added value of this work, we actually give a more emphasis on the 6 Northeast Asian countries. So it's a 6 plus 11 region, 6 regions in Northeast Asia, 11 regions over the world. Actually, that 11 region is same to IPCC message model. However, we ask IIASA colleagues to separate 6 Northeast Asia countries so that we can get a better information independently. So we will collaborate with IIASA people to working on this global aspect of IAM so that we can have some hope to get our future scenarios in the IPCC community. And in the meantime, we are going to collaborate with the ESS Earth Systems model to understand air quality impact under the climate change in the future. Okay, this is the Guide Global Research Team. We have 70 members, including the many Korean scientists, as well as the IIASA colleagues in here. And also, we are working on developing some advanced scientific findings into the policy model, one of which is secondary formation in the policy model. The other is the artificial intelligence-based air quality modeling system, because CTM, chemical transport model, takes a lot of time even with supercomputing system. Last one, but not the least, is the SI project of IIASA, led by Dr. Caroline Jim. It's a just transfer all. So it's aiming for the just transition scenarios to carbon neutrality. So this is very meaningful project, I think. So I'm participating in this project too. So from my perspective in Korea, we are very much worrying about our aging of the population. So this is the aging prospect from year 2015 to 2030. So the peak age is getting older. So we are going in this direction. And another thing is secondary formation of PM2.5 and also ozone production. The secondary, ozone is old secondary, but it's getting more and more concentration as far from the source. So when you see the PM concentration, high PM concentration with high population is well matched, but in the future, we are going to have older people with the remote area. So the ozone concentration in the population center is no longer effective. So here is the ozone concentration center with aged population. So there will be an added impact in the future. That's what we are worrying about, and we are thinking about in terms of from the just transition perspective. Okay, this is my summary. This is young myself in year 2000 at IIASA, and we did Gange Korea in year 2013, and developed Guide Korea with the hint of message and Gange Korea. And we are expanding Guide Korea national system to global and local, then add some science into the policy model. And then we are hoping to have to get benefits from the systems analysis to the society in our country as well as the Northeast Asia, hopefully to the world. So this is the end of my presentation, and I'm going to introduce 3 presenters in the session 2. For the energy system, Dr. Keian Riash and Dr. G. Clement will show the air pollution stuff, and also Caroline Jim for the just transition. Okay, thank you very much for your attention. Thank you. Keian, can you hear me?
Yes, I can hear you. Can you hear me?
Okay, are you ready?
Yes, let me share my screen.
Okay. Okay, Keian, floor is yours.
Thank you. Yeah, so first of all, thank you very much for having me today. It's a big pleasure to be here and to be able to present some of the work that we are doing and also discuss the collaborative activities. It's a pleasure to be here virtually. It's a pity that I cannot be with you this time in person, and I hope I can follow up on that as soon as possible. Professor Jong-Hoon Woo has already introduced some aspects of the collaboration and the GUIDE project. Let me give you perhaps some context of the work, and then also introduce some of the features which I think are really critical and cutting edge in the collaboration that we are planning to do. So first of all, perhaps if we think about, and my focus will be on energy systems, and Zig Clement, who is speaking after me, will focus on the air pollution aspects. But perhaps first of all, I think it's really important to recognize that if you're talking about the energy transformation, we need to think about multiple objectives and very complex interdependencies between different how different parts of the system interact. So transforming the energy system, of course, at the one hand, we need to do it to reduce the greenhouse gas emissions and to address climate change. Climate change and air pollution interact strongly, and Professor Wu has I think, in an excellent way already introduced that issue. But energy systems have also big implications on water as well as on land use, particularly biodiversity and food systems. Increasingly big impacts on food and biodiversity if we rely more and more on bioenergy. And I don't have to explain to anybody that nowadays, given the Ukraine crisis and the increase in energy prices, how energy security is important. There's big vulnerability for volatility in prices, but also dependencies across different regions. And then finally, and not finally, perhaps foremost, we need to achieve this transformation and at the same time combat energy poverty. More than 1 billion people are without access to electricity. More than 3 billion people are without access to clean cooking, which is the main health impact from the energy sector. And we are trying to basically at the IIASA to use our systems analytical tools, message, but in combination with GAINS and other tools to provide an holistic view and look at how we can transform these different systems, and particularly the energy system, to address multiple objectives at the same time. If you think about carbon neutrality, I think it's important to think about to understand, and this is an example of some work that we did recently within the community. global transformations towards carbon neutrality. And if you talk about carbon neutrality and decarbonizing the energy system, I think it's really important to understand that we will not decarbonize every activity. There are sectors which are more difficult to abate, and at the end achieving net zero greenhouse gas emissions, which is necessary in order to climate change, needs to be achieved in a way that we basically do 90% of the job through mitigation, but there will be residual emissions, and those residual emissions need to be offset by atmospheric sinks, so that we have a balance between emissions and sources. And this is shown here particularly on the left-hand side. You can see major emissions reductions happening until roughly around 2070. Net zero CO2 emissions is achieved, and basically emissions reductions are then also complemented with negative emissions, particularly from the land use sector, but also there are options to achieve negative emissions to energy supply. And if you think about carbon neutrality and net zero emissions, I think it's also important to recognize that different regions are in very different circumstances to achieve net zero CO2. It's not clear whether all regions and all countries of the world need to achieve net zero CO2, as it's not clear that all sectors need to achieve it. It's about this balance of emissions and sources. And if you look at Asia, which is the red part down here, most of the global analysis indicate that it is relatively easier, and that's just an indication of the timing when different regions achieve net zero compared to the time when the world achieves net zero in these scenarios. The more to the left you are, the earlier net zero can be achieved, and the more to the right you are, the later. And generally, regions like Latin America or the performing economies of the former Soviet Union, because of abundant land resources, can achieve net zero relatively more easily than regions such as Asia, the Middle East, or Africa, which generally tend to achieve net zero later. And what does this mean at the end? Is, I think, something something to explore in a context where you have, at the one hand, a global framework, but you have also a national framework which can communicate to each other. Another point that I want to make is that the IPCC report, which came out just recently, and this is some insights from the chapter that I had the pleasure to lead in the IPCC. That's from chapter 3 of the sixth assessment report released earlier this year. The main conclusions from the IPCC report on costs is that globally, cost of mitigation is relatively modest. Even for 1.5 degrees or 2 degrees, it's a few percentage points of GDP losses. However, there are large regional differences among those costs. Generally, costs are bigger in regions where we have least and the reforming economies, where we have high dependence on revenues from fossil fuel exports. Costs are relatively lower in economies which basically reduce that dependence, like the European Union, North America, but also Pacific Asia. And there are the costs of some of the Asian economies like China and India is somewhere in between. So these regional differences, to understand the cost, is really important, because we need to find a solution which is equitable. And there is, at the one hand, the consideration of responsibility, but on the other hand, also the consideration of really different costs and benefit of the transformation across the world. And this is another reason why to focus more on the other regional characteristics of those global scenarios. And this is something that we want to do together, as Professor Wu already mentioned, in our IIASA Korea Guide collaboration. One of the innovations in this project is to explore new modeling methods for to provide a bridge across different scales, to basically link activities at the national level in countries like Korea, but also in other Northeastern Asian countries to the Northeastern Asian region, and then look at how this connects to global assessments. This is extremely important because while climate, for example, is a global problem with global emissions and energy resources are traded at the global scale, we need to achieve the transition on the regional level. Many of the solutions have transboundary implications, and there are also regional markets, like for example for electricity. Policies are implemented at the national level, so that's the main implementation level, and that's where energy and environmental policies are introduced, and energy security plays there an important implication. And then finally, it is, I think, important to, at a subnational level, to understand how, for example, electricity grids can be planned, where the renewable potentials are, how they can be integrated, and how demand and supply can be matched in a especially very heterogeneous scale. So all of these layers need to be combined, and the idea is to really go the next step and to integrate those different scales in a much better way. So let me perhaps also comment on, so if we want to achieve very deep and rapid emissions reductions consistent, for example, with the 1.5-degree goal of the Paris Agreement, there are basically two major perspectives of how we can achieve that. One is the conventional way, where many scenarios have suggested that there is a lot of inertia in policy and technology systems, which lead to further increase in emissions over the near to medium term. At the end, this will likely result in overshoot because of reliance on supply side systems, and this overshoot here needs to be compensated in the long term with negative emissions technologies, and very often this means reliance on technologies that are more speculative from today's perspective, which are not available at scale in the market right now. The alternative to that, and this is something that IIASA has been proposing very strongly, is to think about very carefully how we can limit energy demand. How can we achieve a demand side transition through distributed and very granular technologies in order to more rapidly change the systems, because a granular and small scale technology diffuses more rapidly into the market, and to avoid then, because of the accelerated transition in the near term, that we need to rely on massive deployment of, for example, technological solutions that would remove CO2 from the atmosphere. And this is strongly connected also to some of the innovations that we want to achieve together with you and with our Korean partners in the GUIDE project. One of the key innovations, I think, are that we don't only want to look into how to transform the energy system, but we want to understand how we can shift from an energy intensive system to a system which is more material intensive. So if we replace the current fossil fuel based system to a more renewable one, we need more material. It's also a more investment intensive system, but in order to understand how to achieve this, you need to integrate energy and materials, and you need to understand how to recycle and share things in order to also reduce some of the material intensities. So we want to put emphasis also not only on supply systems, but supply and demand systems. I think another really important innovation will be this very close linkage, and Sig Clemens will talk about this in the next presentation, between climate and pollution that we want to understand in this project. Another one is in my view, that there are the so-called shared socioeconomic pathways. They basically underpin the analysis of the IPCC, the Intergovernmental Panel on Climate Change, which has been very influential, for example, in setting up the Paris Agreement, etc. But those SSPs generally are global. And in this project, we want to also look at how do shared socioeconomic pathways look like for Northeast Asia. So how does the narrative within the global SSP look like, and how would the transformation be different, for example, in Northeast Asia? And then finally, Professor Wu has already mentioned this, an innovation will be also to expand the IIASA integrated assessment framework, and particularly the message model, to better integrate the Northeastern Asian countries and to expand it to 6 new countries. At the moment, we have a global modeling system that operates on 11 regions. The new one that we will jointly develop will operate on 70 regions and will allow multi-level interactions between the countries and the regions. That's already my final slide. So what we are doing in the IPCC is that we are hosting large-scale data sets, scenario sets for the IPCC, and serve to that also for the dissemination, transparency of the IPCC reports, particularly now in the last 2 reports, the AR6, the 6th assessment report, but also the special report on 1.5 degrees. You can see down here actually the link. So if you are interested more about the IPCC scenarios, you can download all the information here. Similar scenario explorer and dissemination activities we will also conduct together here in this in the GUIDE project to basically create a hub for Northeast Asian scenarios, and where the community can start to compare scenarios at the national level, but also at the regional level. And because of that exchange, also create a multiplier in terms of collaboration within the region. Thank you very much. Thank you.
Thank you very much, Dr. Liai. We have next speaker from IIASA, G. Clement, will giving some air pollution aspect of.
Yes, thank you very much. K1, thanks a lot for biting quite a lot in my time. So the mic is not on. Let me just grab it and I will run around with the mic. Maybe it's better then. Anyway, that's good to wake up. It's a funny time in Europe. So for us, it's quite difficult. Jung-Hoon, please stop me when I speak too much. I'll be happy to talk to anyone about anything that I'm going to show on the few slides, and I will try to say a few words about air pollution. And I will start with a slide that actually brings in an overly simplified relationship between economic growth, air pollution, and climate change, as a matter of fact. But of course, it's terribly oversimplified, and it does not say anything actually about the action and the interaction and relationship between these different elements. But what is important, and why I'm showing it, actually I put it in because some of the comments early on today in the morning were relating to the scale and across different scales. This is an example also how pollution actually is happening at different scales. That's obvious. But in terms of solutions, this is very important to understand, both from the policy of analysis and the scientific modeling, as well as how the policy is actually tackling that problem, and how it connects between some of the local indoor air pollution problems, very closely related to a lot of social issues that are close to hearts to many, and those larger problems that some of us have not seen for very long, and some of us still don't see, and require different solutions. The point that we are trying to make in our work, and it's seemingly obvious, I mean, it's not seemingly obvious that the air pollution is not one of the sustainable development goals. That actually is strange to me, has been always in a way strange, but there's a number of SDGs that very directly connect to air pollution. And we believe that it is a very good entry point to a lot of analysis that we're doing. I picked up a couple of quotes from some papers that support the thinking and the work that we are doing. The good and bad, I mean, what is important now for work on air pollution is that both developing and developed or industrialized countries are interested still in air pollution. It's not gone. It causes premature mortality, morbidity. There's a lot of effects on ecosystems. So there is a widespread interest to find solutions. Everyone is interested in doing it, and at different scales. The local air quality benefits can actually provide a really good entry point to long-term solutions and improve acceptability of that work. And this is one of the things that we've been ailing when we think about long-term transformations. It's been mentioned today, earlier in the discussions, and I really like that, how science is actually crossing the border to policy or to general public. How do we cross the border between our little working environments on air pollution, climate, or some of the other areas? We actually are not doing terribly well in many of these, but we've been improving systematically. And this is what we are trying also to do, to come across these scales and improve acceptability of the solutions, because we believe this is a very important point. Some of the policies that are decided already or being decided at different scales, both in Europe as well as in Asia, have the capacity to actually enter that path and change that will be a long-term change. The European policy and the Green Deal embeds zero pollution policy and climate policy together, and a lot of work that we are trying to do, and I will show a couple of examples of that, are actually linking to what IIASA stands for and what we've been very interested and excited to do over time and provide solutions. This is very similar to what Albert showed for ASEAN countries, and it shows how committed policies, how important they are to reduce the death toll of air pollution. So all of the gray bars that you see here, these are emissions. This is something that is in the books. This is what we've done, we are committed to do, at least on paper. In reality, unfortunately, it doesn't happen very often, but it allows, assuming it happens, to bring down exposure. This is actually population-weighted PM2.5 significantly. This is where we could be in these regions, that's a selection of few regions, if nothing was done. But just as Albert mentioned today in the morning, there is a lot more that can be done. Actually, more can be done, as a matter of fact, but these blue bars indicate something that we really know how to do. It's something that has been done in many places. It's not that that's science fiction or something that is not actually, we don't know how to do. A lot of that reduces this air pollution that I already mentioned, but at the same time, the other SDGs here in bringing the, sorry for the words, short-lived climate pollutants, black carbon, methane, CO2 at the same time, improving energy efficiency, a lot of greenhouse gases and short-lived forces like black carbon or methane are actually going down at the same time. So this is strongly embedded together. And as I said, this SDG, there is a number of them that are being served by this work. That's one example of work, and it's been done at the global level and regional level. Some of you might have heard about this report, and if you haven't and you are interested in this subject, I would recommend to download that from the CCEC website. IIASA has been one of the contributors to that report, specifically the section about mitigation potential. It is actually a really nice piece of work that outlines the ideas behind co-benefits and put in life. This report resonated quite well within Asia in different communities, been picked up by policy people, been picked up by science, and actually been picked up as a source of inspiration in a way for further work, supported by CCEC as well as UNEP and some of the governments. And here, I'm not going to go into any details in here, but it just shows the necessity to go beyond the classical air pollution measures and put a filter on a pipe, put a catalyst on a car, but think much well beyond that. Look into agriculture. It's not something that normally you would think about agriculture as the source of air pollution, but it is an important part, and it's actually a growing element that in many places becomes more important. This is one of these examples of actually a follow-up work. Now, sorry, the reason I'm bringing it here is not to go on and plow through the details in here. This is a potential for mitigation, similarly to the previous slides for the Asian regions. It's critical to see some of these measures that are, again, committed. It's So important to actually make sure that action that is on paper delivers and is being done and executed. What we need for that, and we tend to forget, especially we scientists, is institutions. And in our work, where we tried to discuss that also with local policymakers, we've been stressing that important aspect of institutions. This is one of these elements of actually crossing the borders between science and different communities, including policymakers and public. That is very important. What I want to bring on this slide, apart from pretty bars, is that, again, as I previously mentioned, this cuts across many different areas. So biodiversity, renewable energy, circular economy, all of that is embedded in some of these measures because we address waste, which is not typically seen as air quality measure. We see agriculture, which is, again, not seen typically, dietary changes, not seen typically as that's the first thing you should be doing for air quality. And probably it's not the first thing, but it's one of the elements if you want to go a bit further and you want to improve on several indicators, including ecosystems and health. One aspect on this busy slide, the good thing about this slide is, actually it's linked to the ASEAN study, that it has only 2 colors. And I would like to focus you on 2 colors and forget the rest. There's 2 countries which are a bit different, Laos and Cambodia, but I want to bring here the aspect of locally generated pollution and locally abatable pollution and what neighbors can deliver. The yellow is what neighbors can do. When we talk about the first bar, clean cooking, or we talk about second, like post-combustion controls, power plants or industry filters, you could see that there's quite different, these pictures look very different depending on the country that you look at. Indonesia would look different, again, in any other country. If you look at these different measures, they have a different component, 1 minute, of a local and external sort of transboundary pollution. Now, this can be very easily misused and has been misused for the blame game and saying, hey, oh, this is terrible, you know, you're polluting my country, you're killing my people. And actually, we try to say it's much more important to stress the element that says there is an opportunity. There's a benefit for all to work together, exchange technology, learn from each other, and perform actually better on all of these aspects. And I think this is slowly happening because there's a lot that we can learn from each other in any region. Just an example. I can skip those because they've been addressed already. So this is just bringing in this ACNEA project and the collaboration between the teams. There's a lot of rationale to work on Northeast Asia. And we are building that, linking to the gains model and linking a number of integrated assessment models and analyzing then air quality policies. This will be discussed, I believe, during the panel as well. And Professor Wu has shown already that, so I can skip that. An example, just one example, and I'm going to finish then with the last little thing, is the example of the net zero policy. Professor Xu Xiao, sitting on the panel in China, probably will say, hey, this is a very pessimistic picture. You see here that exposure to very high levels in China in a baseline scenario are pretty high, nearly half of the population in this baseline scenario. And I agree there's been a lot of work done. This is already a few years old example. But what I really want to highlight here is that there's a huge potential when we look into the net zero. I don't know how to go back, but if I flip between the two, you see here that this gray bar goes like 5 times higher. And this is the exposure consistent with the WHO old, actually outdated already guideline. And so there's a quality of life, a huge improvement in quality of life. Sort of obvious, but you have to calculate it and you have to bring it in. That's an added benefit of actually acting both on climate and air quality. The last thing is very complex, so I will try to guide you in 20 seconds through it. The only thing about this slide is cities are not alone with their pollution. Cities very often think and act like they would be. So they want to solve their problems alone, but they can't in many places. So they need to work with the neighbors, meaning neighboring regions, sometimes neighboring cities. And what we try to do is try to work on that from the modeling perspective and create this completely crazy, unreadable type of slides. But what I want to say is here on this slide, what you see is distance in a way from pollution. That's the concentration. That's the distance from the receptor in a way where we are. And you see here there's transboundary natural sources and there are local sources. Each of them contributes differently from different sources. What we try to understand this is how it changes over time when you do something. So you can do something alone, and you will affect these bits, and this is going to happen. I'm very brave here to bring an example from Korea. So please free to criticize me. But we have those examples for whatever 1,000 cities across the planet. It's a model, so can do anything. But of course, we care about validation of that. But what you see here is national policies. Of course, they bring down these bars. Don't touch the transboundary bar. So international collaboration and international work and an effort that is coordinated, or maybe a global policy that embeds actually climate and some discussion of the air quality, will bring some of those bars significantly down, reducing exposure by half or bringing it down to under 10 micrograms. Thank you very much. Happy to talk to anyone later.
Thank you very much, Jake, for your excellent presentation. So next of our speaker is Dr. Caroline Jin of IIASA. Caroline, are you in the line? Okay, thank you.
Yes, I'm in the line, and I hope that my connection is stable enough to do screen share and the video and everything at the same time. Yeah. Good morning, everyone, or good afternoon. Can you see my screen?
Yes, we can.
Okay. Okay. Who already introduced our Just Transitions to Zero Carbon Emissions for All initiative, which is a IIASA strategic initiative where we listen to our national member organizations and ask them for insights on what they would be interested for us to do exploratory work on. And this Just Transitions initiative, Just Trans for All, is a collaborative effort of our Energy, Climate and Environment program, the Economics Frontiers program, and Population and Just Societies program. I'm leading this initiative, and I'm here presenting on behalf of a lot of colleagues. Also, Konkuk University, as already mentioned, is part of this initiative because we want to work with NMOs in tackling these novel challenges. And what we do is that we build on the strengths of the IIASA programs, and we add a new innovative systems analysis layer to the work that is already there, synthesizing and bringing together these new perspectives. Let me explain to you what our the rationale and the motivation for the project is. So in order to achieve the Sustainable Development Goals and also stay within the Paris Climate Agreement, we don't only need an energy transition and a decarbonization transition, but we also need to account for social justice, to improve acceptability of policies, and also speed up the transition, which also Kevin has shown, and come up with new ways of achieving a low carbon that modeling and scenario work that is available to inform policy making at the level of the Intergovernmental Panel on Climate Change. We don't have scenarios that reflect this multidimensional justice objective. So for example, here you can see scenarios that stay within the Paris Climate Agreement 1.5 temperature guardrail. And you see in red marked all the mitigation efforts, the share of the mitigation efforts that is expected in those scenarios to come from the Global South, which is around 3/4. And in blue, you see the share that is expected to come from the Global North. And this is just one aspect of justice, because justice is highly subjective and has multidimensional, but you could argue that it's not just that the Global South is expected to mitigate more, even though the Global South has to still achieve to provide these services to its population, and the Global South is also disproportionately affected by climate change, which was caused on the other side more historically by the Global North. So this is one aspect of justice that in current scenarios is not reflected. The challenge though is also that because justice is so multidimensional and it's subjective, it's really hard to feed this into quantitative modeling. So there's no way currently that could guide how modelers should go about this problem. And this is where we come in our initiative, building on IIASA trademark research. We are grounding our approach in the Decent Living Standards Network, Decent Living Standards approach, which focuses on providing everyone with decent living services overcoming multidimensional poverty, because we argue that the objective and the outcome of any just transition should be actually higher levels of well-being, and that scenarios should reflect to achieve bringing people out of poverty, but not only out of economic poverty, but actually looking at the services that are really related to high levels of well-being. And this is also grounded in the Sustainable Development Goals. And what we do now in our project is multifaceted. We look both on the conceptual framework and how to incorporate this into modeling. We also work with a philosopher on this to really ground this in solid, I would say, justice perspectives. But then also we want to look empirically what science says about, what data says about how our access to decent living services connected to actually higher levels of well-being. And with all of this together, we want to advance the scenarios that are then used for policy making to bring them to a new level on justice, with the focus on human well-being. So what are possible impacts on science and policy? I already said this, that we are aiming for one, a conceptual advancement. So really the first just operationalization for modeling. And we're responding both to a scientific debate, but also political debate, because policymakers have argued that the scenarios are not reflecting different justice concerns sufficiently. We also hope that we can bridge to new communities that are using the scenarios, and thus also improve the scenarios that are being used by the IPCC. Because also a lot of humanities and social sciences are now starting to pick up those scenarios more, but they can also feed into them and improve them. And then also we want to guide national policy making, where a lot of just transition energies strategies are being developed, linked into the SDGs, focus on these human well-being outcomes of all these strategies and the social acceptability. It would be great if, for example, in Korea, this could be one of the case studies. And with this, I'll stop my intervention and look forward to the discussion and questions.
Okay, thank you very much, Caroline, for your excellent presentation. It's time to have a panelist discussion now. So we actually invited two researchers, scholars from outside of Korea, one from China and the other from Japan. So Xu Xiao, okay. Professor Xu Xiao Wang of Tsinghua University. Xu Xiao, can you hear me?
Yes, can you hear me?
Okay, good. Please.
Thank you. I'm Xu Xiao Wang from Tsinghua University. So I'm very honored to join this workshop. It's great to see, our three speakers to talk about the most recent research, and also great to see a lot of friends like Zig, Jinhun. Yeah. So there actually have been a lot of collaborations between IIASA and China, and also with Korea. So the topics between us range from air quality to carbon neutrality. So it's been a lot of outputs from the collaborations, and the against China and all the other integrated assessment models have revealed a lot of insights into the current sources of air pollution, which affects the human health, and also about the future pathways for sustainable development in China, as also they indicated that not only for China, but for Asia Pacific regions. So in terms of China, I want to say that as the largest developing economy and the carbon dioxide emitter in the world, the carbon neutrality goal of China have a profound influence on the mitigation of the carbon dioxide in the world. And also, previous studies, have shown that our clean air actions in China since 2013 have brought us a lot of carbon reduction co-benefits. And looking into the future, China has this air quality, beautiful China target to have the air quality attainment by year 2035. So to achieve that target, the end-of-pipe of control policies actually have exhausted to further reduce the emissions of different air pollutants. So the carbon peaking policy and the carbon neutrality policy bring us the opportunity to have these win-win solutions. But we also are facing big challenges because China is heavily relying on the coal for the energy structure, and the heavy industries such as cement, iron, steel, and coal and petrochemical industries are taking a lot of the economy in the China situation. And also think about the carbon neutrality from 2030 to 2060. We only have 30 years to reduce our carbon dioxide emissions by 90%. So I mean that the carbon neutrality is actually an extensive and profound economic, social, systematic reform for the whole country. So there are, although there are a lot of suggestions and the results from the previous studies from our collaborations, there remains significant gaps between the research and the actual experience by implementing the solutions to air pollution and to climate change problems. So I think first is that the interlinkage between air pollution and the climate change still need further investigations. For example, that the extent to which the carbon neutrality targets will align with the 2021 World Health Organization global air quality guidelines having not been well evaluated. So in this collaboration project, we would to examine the air quality improvements in China under different future energy scenarios, under the carbon neutrality pathways, using this integrated assessment modeling system. So some preliminary results is that the carbon neutrality pathway, of course, have large co-benefits on the sulfur dioxide, NOx, and the PM 2.5 reductions. However, there are still a lot of Chinese cities do not meet the WHO air quality guidelines by year of 2060. So that means that non-energy related air pollutant sources, as mentioned by Dick, that agricultural sources and the VOC related sources will become increasingly important. So additional air pollution control measures beyond the carbon neutrality are still necessary. So this would ask us to do more analysis. And second is that when we consider about the control measures, that more, yeah.
Can you keep it short? I'm sorry, but it's already been delayed.
Okay,
so,
yeah. Just 2 sentences. Okay. yeah. So, I mean, the current analysis, we see that it's all the country basis, right? But the cities are those who will implement the control measures. So, I mean, the cost effectiveness assessment and on the city scale pollution control measures, I think need to be further studied in the future. Yeah, so that's my suggestion. Thank you.
Thank you very much, Shishao. I'm sorry to make you hurry because we are already behind the schedule. Thank you very much for sharing your insight. The next panelist is Satoru Chatani of NIES, Japan. Okay.
Yeah, yes.
Yeah, please go ahead.
Yeah, okay. Thank you for inviting me to this very good conference. So I just briefly want to explain about the situation in Japan. So for the air quality situation in Japan, so PM 2.5 and ozone concentration still be higher than air quality standard. So we have to reduce this pollutant concentration. So now Japanese government are interested in the two factors for this pollutant. The first one is a co-benefit with the climate policy. So because new carbon neutral policy is kind of a top priority for Japanese government. So they want to know how these kind of policies are effective to reduce not only carbon dioxide and also GHGs, but also the precursors emission for air pollution. So this kind of co-benefit is very important. So that's why we need to know what kind of co-benefit can be obtained by implementing the carbon neutral policies and additional air pollution policies. This is important one factors. And another factor is transboundary transport. So we know the influences of transboundary transport is very important in Japan. But also, as Jake mentioned, so transboundary transport, for the issues of transboundary transport, international collaboration is very necessary and important to tackle on this issue and also improve the air quality over East Asia and also Southeast Asia. So we are now trying to have collaboration between the government and also in the science community. We have various framework to tackle on the air pollution, transboundary air pollution issues. So these two important factors is included in the project led by Professor Wu. So now we are now participating in this new good project. So in this project, we want to get a good result, and also we want to provide such kind of variable findings to the government to promote, to solve the issues like climate change and also air pollution over not only Japan, but also Asian countries. So thank you.
Thank you very much, Dr. Chatani. We have two panelists from Korea, Dr. Yonggon Kim of KEI and Dr. Yara Che of KEI. So, Dr. Kim, can you give us some, share your insight, please?
Thank you very much for inviting me to this 50th anniversary for IIASA conference, and thank you IIASA and IIASA and the NRF and Korea University and Konkuk University. And I really I express my sincere congratulations to the 50th anniversary of IIASA. I think IIASA, as you all agree, I think IIASA has made a great achievement to a lot of scientific issues, problem solving for global community, including the climate change. As a lead author for IPCC assessment report for the 5th and 6th cycle, I see the great support and contribution from IIASA to, for example, they developed their own great model like the message and also the gains model. And also they are constructing the great database for a lot of climate scenarios. And all those are really, we benefited a lot from those IIASA's effort. And from the presentations of today, I see the great progress also for the cooperation between Korea and IIASA from the Dr. Wu's presentation. That case is a really good example of this kind of cooperation. And I will introduce you for my researches. And I'm also modeler for the Global Integrated Assessment Model. It's mainly a global economic model. It's a kind of computable general economic model. And it's already explained by the K1 on the kind of economic impacts from carbon neutrality. I also have done such kind of researches. And I really want to talk to you today is that Korea is a country that can benefit most from carbon neutrality because, you know, Korea really heavily dependent on the fossil fuels imported from abroad. And if the global community really achieves carbon neutrality, then we also reduce the fossil fuel consumption almost to zero. And the fossil fuel global price, international prices might go down also to almost zero because the demand is nothing at that point. So we will see a huge, rapid decrease of energy prices, although we see the opposite case these days, but that is very temporary, I think. If all the global community will try to achieve carbon neutrality, certainly demand should decrease, and then the price go down. So Korea can benefit from this kind of international price decrease of fossil price, and also we will reduce our consumption and also our import. So based on my global multi-regional CG model, then Korea is the country with the biggest benefit from this carbon neutrality. And so that's one point I want to share with you. And also on the air pollution impacts of carbon neutrality, I have done the power sector optimization model simulation. And from the simulation, even we achieve the carbon neutrality in the power sector, but the air pollution doesn't disappear. You know, that's because the hydrogen combustion and the CCS technology should be part of the solution for the carbon neutrality. Then those technologies still, there is no CO2 emission from those technologies, but a lot of air pollution like nitrous oxides and ammonia, those is a very serious air pollution still remaining even with the carbon neutrality. That's the 2 points I want to share with you. And thank you very much again. And I really congratulate the 50th anniversary. Thank you.
Thank you very much, Dr. Kim. And Dr. Che, please.
Good morning. I'm Yora Che from Korea Environmental Institute. As you are very hungry at this moment, so I'm trying to be quick. Yeah. First of all, many congratulations for 50th anniversary of IIASA. I first known IIASA for my graduate studies. I used the RAINS model to trying to combine with the PAGE model to see climate change and air pollution together. That was a long time ago, and at that time it was very hard to share the data between two models. Yeah. So, and I'm very glad that now many people think it's the importance of climate change and air pollution together, not the climate change and air pollution alone, but also trying to integrate science and economics. So normally two sectors do not talk each other, and they use different language and different view. So IIASA has many contributions for that way in the global research community. Yes, I'm very thankful for your data and models. Yeah. And right now, I'm doing research on estimate cost of inaction of climate change. So what will happen if we do nothing to reduce carbon dioxide? What is the impact of cost of inaction for many sectors: health, agriculture, fishery, water resource, tourism, and every sector. So by doing so, we can see the benefit of cost of action. So we can, in economic way, we compare the cost of action and cost of inaction. But there are many ways to do that. So we can only quantify the benefit in certain city or certain country or global or regional, Northeast Asia. And it is all different. And it also depends on the time, whether we consider 20 years, 50 years, 100 years, the priority is different. So holistic view or systematic approach, integrated assessment is very important. And we have to quantify that cost of action and cost of inaction or cost and benefit for including co-benefits of air pollution and water quality, sustainable development in every way, and trying to communicate with policymakers in the world. So, yeah, I have to be brief. So, yeah, and thank you very much for your all good presentation and all good things I already said. So, thank you.
Thank you very much, Dr. Che. Since we are still very behind the schedule, but can you have take one question? Okay, thank you. So if we do not act now, then we will be a climate villain for the world. And if I do not stop this session now, I will be a lunch villain for now. So thank you. I wanted to close the session. Thank you very much for the speakers for your excellent talk, and the panelists for the sharing great insights, and audience for listening. Thank you very much for joining us. Thank you. Have a nice lunch.
One small notice, the lunch will be served to your table, so wait a second, and then they will serve your lunch in your desk. Thank you.
Hi, good afternoon, everyone. I trust you all had a good lunch. Usually we call this a graveyard session after lunch, when people sleep generally. But we're going to try and ensure that this session keeps you awake and keeps you alive and keeps you interested. So let me start by firstly thanking our hosts, the NRF, as well as Korea University and Konkuk University for hosting us. I'd just like to also thank on behalf of IIASA all the people behind the scenes that actually worked to make this happen. And then, of course, let me thank my colleagues from IIASA back in Luxembourg, Austria, for all they've done to put this together. Just to give you a context of this session, and I'm going to call it a fun session. To give you a context, when we were approached by Korea University and the NRF, both Albert and I were approached, and they want to have this meeting, one of the things that Mr. Park from the NRF asked is that, what is IIASA? And what is systems analysis? And what do you do? I said, why do you ask those questions? And he says, well, many of our students don't know what it is. And we need to spend the afternoon discussing systems analysis and discussing the methodologies and discussing the impact of it. So what you witnessed this morning were very high-level talks of the applications of systems thinking and systems analysis in addressing certain global challenges to try and provide solutions for society. That's what you saw. What we're going to do this afternoon, with the help of our very able colleague Fabian Wagner, is to demystify the methodologies that are used in order to be able to do that kind of research. And I think the idea is to simplify the abstract so that it's meaningful, it's understandable, and our students can walk away with a working knowledge and a shared understanding of how we go about these things, so that when they conceptualize their research, it becomes a lot easier. We also believe in evidence-led presentations. So what we're going to do is that besides Fabian and Suzanne, who's in Austria and will join us virtually, besides those two presentations, we'll have some of our researchers at IIASA who are from Korea, who are research scholars, to explain how they've applied systems analysis to their piece of research and describe their research. Then at the end, which is a discussion between all of us, is largely to solicit questions from you, but to look at the application side of the methodologies used for both systems thinking, systems analysis, how to understand the looping structure of systems analysis, etc. So Fabian, let me invite you to come and address us on the methodologies.
Thank you, Gansen. Good afternoon, and thank you very much to the organizers for inviting me and us to participate in this session. So again, I'm well aware that I'm fighting against the sleepiness of the afternoon, but I hope that I will succeed. So my presentations is about methodologies. Gansen introduced the topic very ably. So the first question that you may have really is, what is the applied systems analysis in the name of IIASA? What is applied systems analysis? And let me just go back and take the opportunity to go 50 years back to the time when the Institute was founded. There was a period when the negotiating partners who wanted to found this institute had to decide on the location, and eventually they settled on Austria. And then they had to decide on the name, and there were various proposals on the table, but the founders couldn't agree on anything. And so then Howard Rafer, the then first to become the first director, had an idea. He said, I wrote a book called Applied Statistical Decision Theory. And everybody said, what do you mean by applied statistical decision theory? And then he said, oh, that's the idea. Okay, we call the institute the International Institute for Applied Systems Analysis because then nobody knows what it actually means, and everybody can take home whatever they like and project onto the name whatever they think systems analysis is. And that actually helped the negotiations along, and up to this point, people project onto applied systems analysis whatever they want to think it is. And I hope by the end of this session, or at the end of this lecture, we have a clearer understanding after 50 years doing applied systems analysis of what it involves. The short answer is there is no one definition. It's a set of practices, and I will specify what it actually means. And to brace yourself, I'm not going to talk about all kinds of very specific modeling methodologies. You've seen today in the morning already very specific modeling, an overview of modeling, including uses of machine learning and GIS and remote sensing and so on. Everything that is part of what we do nowadays in modern systems analysis. But I want to take a step back and think fundamentally about systems first. So my agenda for today is talk about systems thinking, then talk a little bit about methods, but from a still relatively abstract point of view. And then at the end, I'm going to talk about some outstanding results, maybe with a focus again on what was the systems analysis behind it and not just presenting the results that you're already all familiar with. So systems, let's start with systems. What is a system? Here's the definition, or here's one definition of what a system is. Actually, there are two definitions. So the second one says a system is composed of parts, and they interact. They're connected and they interact. They have internal relations, and they're interacting in such a way that they achieve something. In summary, when we talk about system, a system always, a system needs elements, it needs interconnections, and it needs a function. Often we kind of overlook that there's this function essential to a system. And the interesting thing about systems is that they behave in a way that is intricately related to the actual structure of the system. We'll see that at a later stage very clearly. Now, what are examples of systems? Here's a few. A mechanical clock. We immediately recognize the elements, the mechanical parts that work together, that are mechanically connected, and with the overall purpose of showing the right time when it's the right time. The digestive system is there. It has also its interacting parts, and it's there to convert food into energy that is useful for the human body, and so on and so forth. We know all these physical systems very well, but then there are also other systems, which we call social systems, and one of them is science. Science is also a system, of course, consisting of various elements that interact with the overall purpose of generating knowledge. And so a system, you've all seen these pictures, or at least you've heard about it. A system really is bigger than the sum of its parts. We all often stand in awe in front of systems and understand individual aspects, and we get our ideas about what these aspects are, but we typically never grasp the full system, and we need sort of the outside view. We need to step outside often, out of our own sort of conceptions to figure out what the overall system really is. And with this insight, of course, we have then access to other new insights when we understand what the overall system looks like. Okay, how can we represent systems? Again, very basic. This is almost systems analysis 101. We may represent systems in this form. We call this influence diagrams with the obvious elements and the interactions between the different elements. Here's another way of representing systems where we label the individual nodes of this diagram, or of the network, if you like, with particular elements. So we have here a clear recognition of what the elements are and how they influence each other. We call this a causal loop diagram. On the one hand, we call it causal because we really want to represent that one thing is influencing the other. And it's a loop diagram because you can see already that the results of this particular action is feeding back into the earlier parts of the system. That means that when you analyze a system, there's no wrong way to start. Anywhere is a good start. You can start analyzing a system from any starting point. There are other ways to represent certain systems. We call these diagrams stocks and flow diagrams with the obvious connotations. The bathtub is a good example of what's going on. I always ask that question, how do you get the bathtub full? And often the response is, well, you open the inflow, you let more water into the bathtub, but there's also an outflow. And if you really want to fill the bathtub, you need to make sure that the inflow is bigger than the outflow. Just having an inflow is not enough. Stopping the outflow is also not sufficient. So here's a good example of how we use stocks and flow diagrams in systems analysis. The example is the population and the population dynamics. Population is considered a stock, which is something that behaves relatively slowly, whereas the flows can change rapidly. And what you can see here in this diagram is that the population actually influences the number of births, and it also influences the number of deaths, as we would expect it. A large population has more births than a smaller population. And so what we have here is a feedback loop between population and births, and whether a population grows or shrinks over time depends very much on the relative strengths of these various feedback loops. So feedback loops are inherent to most of the systems, most of the interesting systems that we are studying. Now, considering this, people ask often, okay, so what is this then that you do, systems analysis? And the starting point is really a particular set of mind, which we call systems thinking. And the characteristic of the systems thinking is that it is loopy. Loopy in the sense that we don't not just think in terms of causal chains that go from A to B, or in this case from A to D, but that we recognize that in any system there are feedback loops, so that we cannot really say there's a sort of root cause of things. Another way of saying this, of course, is if we look back at history, and we keep saying this in the context of IIASA, often the problems that we're facing now used to be the solutions to problems 20, 30 years ago. So the reason why we are facing climate change is because we've been using fossil fuels, but the use of fossil fuels is directly related, was kind of invented, if you like, during the Industrial Revolution also to avoid the cutting down of trees in order to produce energy. So fossil fuels had obviously their good reasons to be there. Now, systems thinking is, I said systems thinking is loopy, but more generally, systems thinking is sort of a set of skills that you can really acquire. It aims at sort of understanding systems better, predicting behavior of systems, and so on and so forth. So that's the terminology for systems thinking. Here's again the example of population growth. We've discussed births and deaths and how they're related to population, but of course there are other dimensions to this. Immigration and emigration play a role in the overall size of a population. And the question is, what determines this? On the one hand, we have discussed feedback loops, but are there also external factors? And this is a diagram that some of our colleagues here at IIASA have produced. They've identified at least 4 characteristic external influences, or maybe also intrinsic influences to societies that need to be studied to understand fully this population, this demographic system. And I want to just focus on 2. They have already been, well, one of them has already been mentioned by Albert this morning, and that is education. IIASA is famous that they kind of were one of the first groups, our colleagues were the first groups around the world who recognized that fertility is strongly correlated with education. And so they focused on a whole research program to estimate better educational attainment in different parts of the world, and also use this to make projections. So Albert showed this for Korea, and this is historical data and then projected into 2030. If we look at different countries, this is now for India. We may want to look into the future, in this case into the year 2070, for alternative scenarios. And what is shown here is that depending on the underlying sort of narrative or storyline here at the bottom, we will have very different outcomes for India, ranging from relatively low development, where the educational attainment is sort of falling backwards, and then in contrast to that, we have a rapid development where education and fertility change rapidly until 2070 with all its implications. So this is one example of where we need to look at how populations changes over time. Another factor that is important for getting the balances right in the system is to understand migration and the various drivers of migration. And here again, our colleagues from the population program are sort of spearheading a number of studies to understand better how migration works. And one of the things that they have done is reconstruct the migration statistics and try to identify what are the individual drivers and how they're related, so that this information can be used for projecting into the future to better understand what a future climate, for example, would do to migration within countries, but also internationally. Okay, now we've introduced systems with the example of demography. I now want to turn to systems analysis methodologies. And again, I don't want to go into all kinds of details, but rather give you sort of a broad outline. In my mind, the methodologies or the kind of approaches that we use at IIASA are falling into three boxes. The first box is kind of a mindset. Systems analysts have a particular mindset. So this involves this loopy systems thinking that I've already mentioned, to think in these causal loop diagrams. It's highly interdisciplinary, so that may be something not familiar to you. It's intercultural. I mean, you see that all of our work that we do is largely at the global scale, or at least at the regional scale. So we need to be able to understand each other at a cultural level as well. It needs to be transparent. We need to use open data so that we actually gain the confidence and the trust of decision makers. Recently, I've learned a new term. What we do actually is teams science. We're not sitting in our cubicles and writing all our papers individually, but we're often working in teams that have all these attributes, being interculturally sensitive and so on and so forth. The second box of methodologies really, really relates to modeling methods. And you've seen today many different tools, many different models, and one can classify these and to get a better overview of what is actually belonging all to this box. We're using simulation models, we have process models, we have optimization models, we're using network analysis, agent-based models, and so on and so forth. The key point is that for these models, what is really behind these models is that we want to develop alternative views on the future. Different futures are possible. One of the traps that we can run into is that we're thinking that we're doomed and there's no way out, but we need to think about alternative futures, and that can be done with models to create different narratives, different scenarios. And the third box of methodologies or approaches is what I call meta modes of systems analysis. And into this category, for something that has been described as systems analysis as a craft versus as a science or as an art form, and I'll come to that in a minute. Integrated assessment, we've heard the word a lot today, integrated assessment modeling. I'm going to show you a little bit more how we define this and what it actually means. Participatory modeling is something that Susanne will talk about later, and co-design as well. Oh, this is already been there. So the point is that, like in every discipline, systems analysis also has its particular vocabulary that applies to all systems, or at least to all systems that you're interested in. And this vocabulary includes terms like synergies and trade-offs, incentives, low-hanging fruits, robust strategies, scaling up, institutional learning, public goods, no-regret options, and so on and so forth. So there's a particular vocabulary that we are all familiar with, and that is cropping up all the time in these discussions. And you as students will be encouraged to familiarize yourself with that vocabulary as well. It's very, very useful. It's at the heart of what we do. It's how we frame our analysis. I've mentioned the notion of crafts of systems analysis. What I mean here is that there is a number of issues that need to be addressed in a systems analysis, if you like. And the first four items we've sort of already touched. What's the real problem? How can we describe it in a causal loop diagram, and so on and so forth. But the bottom half is really interesting now from our point of view now, and that is when we do systems analysis, what we have in mind is always a decision maker. We are not interested in systems that are kind of out there, and we're not doing astronomy where galaxies are kind of not under human influence. We're always interested in a decision maker. And when we talk about decision makers, we need to understand what are their objectives? What is their space of options that they can decide upon? What options can we present to them that they can decide upon? We just had recently a conversation, somebody was asking me, so you have so many scenarios, you can do this, you can play this game infinitely to generate more scenarios. No. Here in real systems analysis, we are boiling it down to really distinct options that need to be decided, and not hundreds necessarily of scenarios just for academic purposes. So this is an essential part of systems analysis, to think about the decision maker. Now, integrated assessment is something that many of us do, and I'd just like to bring out the essence of what we mean by that. We often hear about integrated assessment models, and we often mean that it's actually a model that combines, let's say, an atmospheric model together with an energy model, or a land use model with a climate model, and so on. So what we mean, we're integrating different types of models or different kinds of disciplines. But more broadly speaking, integrated assessment is really a process. It's a process that involves interpreting and communicating knowledge and generating new knowledge from different scientific disciplines, so that you cover the whole problem, yes, but you gain new insights by taking this synoptic perspective, by putting everything together. And not only that, not only do you get a bigger whole than just the sum of its parts, remember the elephant, but you also provide useful information to the decision maker. That's the essence of integrated assessment. And so on the right-hand side, you see this is really an iterative process between knowledge and action. That's why we highlight this, and it's not just empty words. So participatory modeling, again, it goes in a circle. You start out planning, then you model, and then you look at the results, and then you plan anew. And you can do this not only within your modeling team, but also with the policy makers that look at your results and then refine the questions that they actually have. So this is very different from the old communication model that many people still have, that you have science, and science is communicating to policy, and then policy looks at this and puts it on the shelf and decides otherwise. But it's really a sort of co-creation, a co-design of knowledge that is relevant for the decision maker. So here's a very crude picture, a very big picture of what's going on. We have population driving economic activity. There's water use, there's food production, there's various relationships between. It's kind of a system of systems, if you like, many subsystems interacting with this. And what we do at IIASA, we also frame this then in two ways. One way of framing it, the whole thing in terms of risks, and another way to frame it in terms of equity. And there are many other ways you can do this, and I'm probably doing injustice to other colleagues of ours who frame this even in another different way. But this is the big picture, and to address this system of systems, IIASA has built, as Albert and others have mentioned already, sort of this integrated modeling framework. We're not just making this for the fun of it, but we want to address the problems that arise from the systems of systems. And this has many components. You've seen this before. Up there is the population. We need to understand the drivers of the system. Behind the energy planning is a whole energy systems model, the message model, and then behind the land use is the GloBiome model and the G4M, as we have already seen in earlier presentations. So that's kind of how we approach some of these problems, but not only. But the integrated assessment framework is a very powerful tool, and it allows us to participate in these large-scale international activities, amongst them the IPCC. K1 has mentioned this a number of times, that IIASA is very prominently engaged in the IPCC, and this is only possible by bringing together the different expertises and bringing it into a coherent framework. Okay, so in summary, applied systems analysis is a number of things. Applied systems analysis involves loopy thinking, so this systems thinking in general. It's by definition interdisciplinary. It's modeling, but it's not only modeling. Let's be very clear, it's not just modeling, but it's a process. It has already the decision maker in mind. And it involves decision makers and stakeholders right from the start, so that when we get to the results, we don't have this tough communication problem, but we are already in communication and we have a joint understanding of what the issues are. So applied systems analysis is a lot of communication. And we at IIASA also work hard on training our younger colleagues on communicating with decision makers. And it's a long-term effort. It's nothing that you can just write a paper about in a year and then be done with. Okay, outstanding results. I think Albert and others have already highlighted many, many interesting results. I just want to go quickly through a number of things that may have not been mentioned so much, and maybe some aspects that have been overlooked so far. So the first results are about resilience. Resilience, as you know, or as defined here, is the ability to bounce back after a shock. And so another word for this is elasticity, the ability to recover strength, spirit, good humor, or any other aspect quickly. So you have a crisis, and then it takes some time to recover, and you may actually, after a crisis, even exceed your previous state. The point here is that resilience is a systems property. This is nothing that you can see when you look at individual parts of the system. You can't take a system apart and say, where's the resilience? In the same way that you can't probably take a human body apart and ask, where's the soul? So resilience is a systems property, and it's not visible until it hits you. And the important thing here is you don't want to disturb the system and find out whether the system is resilient. So what do? You model, and this is what some of our colleagues have done. They've asked themselves what happens if we have economic shocks that hits our economic system, and they wanted to know how fast the system can recover, and they did this more at the sectoral level to understand which sectors are particularly resilient rather than just thinking about the whole economy. And they found some, of course, interesting results, namely that the susceptibility of individual sectors actually, of course, depends on the country and on the sector and on the time. And with this insight, you could better understand how actually economies grow and how you can make them more resilient. Food choices is another interesting result. We've heard a lot about food systems so much, but what I want to highlight here is, again, a very high-level article produced by IIASA colleagues that used the basic causal loop diagram functionality, if you like, something that we just learned in the previous part of the sector of this presentation. So they've started to use these causal loop diagrams from bottom up to ask themselves, what are the top drivers to reduce meat consumption and avoid these bad environmental impacts? And they found that social norms actually are one of the main drivers here. And the way that they did this is they've used a model that I want to highlight here, which has not been mentioned. It's the Felix model. And one of the things that I want you to notice, one is it basically looks like an integrated assessment model, like the whole framework that we are running at IIASA, but at a much smaller scale. So what this tool does is it allows you to explore these questions without having to run a multi-million-dollar machinery, but still get to the essence of what's going on in the system. And so it has its value. We call it, I would call it Phelium is of medium complexity, and it adds to the diversity of models that we need to understand and to analyze systems and the challenges that we are facing. So this is not a silver bullet, but it adds to the diversity and adds to understanding the uncertainty that we are dealing with. Food, water, energy nexus has been talked about a lot today. Again, I don't want to go into the details. It's this connection, and you know how all these elements are related. So again, what I want to highlight here is another tool at IIASA, which is not the full integrated assessment framework, but what is called the Fable calculator. And what this is, it's a tool that is run in Excel, which means that it can be operated not by modelers, not only by modelers, but actually by decision makers themselves. They can test their own assumptions in a simple tool like this and identify synergies and trade-offs between the different SDGs in that nexus area. And what it also does is it brings together a whole community of modelers. It's not just operated out of IIASA. IIASA is just one partner in a global consortium of about 20 research teams in 20 different countries that have built the framework and then use this for national analysis. So again, what I want to highlight here is that this is emphasizing the notion of transparency, collaboration, international perspectives, and so on and so forth. Also, that is a highlight of IIASA and a highlight of systems analysis. And then biodiversity, you may have seen this again, a very high-level publication coming out of IIASA, bending the curve of biodiversity loss. We are currently on a trajectory to losing biodiversity very, very rapidly, just following the trajectory of what we've done in the past. But there are ways to bend the curve and go up again. And this is an intermodal, again, an intermodal comparison, or sort of what's the right word? I forget. It's again, obviously a large collaboration coordinated by IIASA of different expertises, different modeling groups around the world, to make something like this happening, identifying the main factors and really giving out a roadmap of what needs to be done to reverse the trend. And then finally, I think, Zig has talked a lot about it, but what I want to really highlight once more, independently of the very complex graphs that you've seen this morning, IIASA has been instrumental in shaping air quality policies in Europe. So this is not just an academic exercise that we do and we apply the Gaines model and have some nice graphs and so on and so forth. But Europe and other parts of the world they're also sort of following this trend, are using these kinds of tools for science-based decision-making. And that's where IIASA really has a lot of expertise and experience that we can share. Okay, this brings me to the final slide, the summary. I hope I've convinced you that systems are ubiquitous. Everywhere you can see a system and you can start to analyze it. As today's challenges, as the SDGs, all of the underlying systems are interconnected, and we need to understand better the underlying systems and apply applied systems analysis. Think about what are the options, who are the decision makers, and so on. We need to identify the options, assess them, and offer perspectives on mutual benefits, the power of cooperation, and our responsibilities as stewards of this world towards generations to come. That's really important. And finally, of course, IIASA is at the forefront of all of these efforts, and we are looking forward to many of you to meet you and to help you engage in systems analysis as well. Thank you.
Thanks very much, Fabian. Fabian is actually our Dean for Capacity Building and Academic Training at IIASA. Yeah, Fabian, when you used the word ubiquitous, it was the one word that cropped up in our first lectures because I did microbiology and bacteria were always found to be ubiquitous. So you see systems being ubiquitous as well. But it's amazing how we borrow from biology in systems analysis. I mean, we've got IIASA, a catalyst for enhancing systems analysis research. And essentially, IIASA is a game changer. It's able to make this change without itself changing. And then, of course, you would see the wonderful word synergism manifested a lot in systems analysis. But synergism is a biological interaction that allows two or more entities to bring about an end product which neither could achieve alone, or bring about an outcome or an impact. Fabian spoke about systems analysis. We're now going to move on to systems thinking. Suzanne, are you online?
Yes, I'm here.
Excellent. Please go ahead. Thank you.
Thank you very much. I hope you can also see my screen, but I think that looks good. I hope somebody will notify me should you not. Yes, so I'm really appreciating the chance of presenting today. Unfortunately, long distance, but I'm glad that this is so easily possible these days. I also really appreciate Fabian's presentation because it really set up well what I would like to do. He hinted a little bit at participatory modeling approaches, participatory systems analysis. And what we do in the FairStream project, as part of the FairStream project, really is to think hard about how we can make system thinking and what kind of systems analysis that we do in participatory processes more visible, really. And we're talking here particularly about the idea of co-production, which for our purpose is the same as co-creation and co-design in this context, and which is a very particular form of participatory systems analysis, if you like. The FairStream project is a IIASA strategic initiative project and has actually a sister project also at Korea University. And so we're really extra happy to be here today and talk about some of our work. It is a Nexus project as well. So thematically, we're operating at the food, water, and biodiversity nexus. For scoping reasons, we had to leave out the energy part a little bit. And what we are doing quite differently, really, than what a lot of the traditional IIASA work is doing, is we are not doing what you see here. So we are not working at very high level nexus issues, global nexus issues, but we are going quite locally. And we believe that this is important, an important complementary aspect. And you probably talked about some of the fundamental features of nexus research earlier today. I did not listen to these presentations simply because it was, well, very much in the middle of the night. But I briefly wanted to reiterate, right? So obviously nexus research by definition addresses multiple domains and sectors. So it requires diverse expertise and integration of diverse qualitative and quantitative knowledge, which refers to at least being interdisciplinary. Most often, nexus issues are extremely complex. That is, they're associated with deep uncertainty, high stakes, and not one solution or one expert being knowledgeable enough to solve this problem. So it requires inclusive treatment of very heterogeneous actors. And this refers to the idea of transdisciplinarity, which becomes increasingly salient in systems analysis. So it requires us to contextualize and understand and effectively govern new approaches that go beyond maybe simple participatory engagement as we have known it. So, okay, there was a little glitch. And that is particularly important because nexus issues are regionally and locally extremely different, right? So the overall view is important for international governance efforts, but as we see, global governance efforts are often very, very slow to work and very, very difficult to operationalize. So we need to go regionally and locally into specific contexts in order to make sure that we can govern specific setups and make sure that while we're still struggling globally, it might be easier to achieve something on the ground in a set of different contexts. And this is where co-production is particularly important, but also particularly challenging. We assume in our project that almost everything is systems analysis. A lot of things can be that. Think about a system and you're almost doing systems analysis. But explicitly enabling system thinking requires an additional effort. And we believe that this is worthwhile, particularly in the face of Nexus issues. And I would like to guide you through a few aspects of this, specifically enabling system thinking in a co-production process. So what I'm showing you here on the left-hand side is what is a transdisciplinary research process. And it's not very different from any other research process. The important aspect really is that it does involve stakeholders. What is less visible in such a simple heuristic diagram is that ideally a transdisciplinary research process enables co-production at every stage, or potentially at least at every stage. And co-production refers to enabling the social scientific framing, so including scientific discourses and social discourses as diverse as possible to give us this chance to address the kind of complexity that we're facing in Nexus issues. So a co-production method specifically then is a knowledge support for representatives of different thought collectives, of different ideas, in better understanding each other's ways of thinking, in relating their thought styles to each other, and to jointly generate something new. So the highlighting really is not on, just picking up knowledge from stakeholders and then including it in our scientific work, but really working at the same level and trying to produce something together. Thus, specific criteria of co-production methods are that they help bridge these different thought styles and worldviews and perspectives, that they're easily accessible. So you want easily accessible language, you want easily accessible tools. They develop a shared understanding, or they identify agreement or disagreement, but you do not force any kind of consensus in such a group. So potentially you get, a set of different framings that might be relevant and that need to be considered. And each co-production method can be used at different stages of the transdisciplinary research process. Or, if it's very complex, actually prescribe an entire TD process. So these methods are very, very diverse. And in Fairstream, on the left side, you see a list of the kind of methods that we've reviewed, methods that are in operation at IIASA. These are, for example, a rich picture, participatory systems dynamics, as Fabian has mentioned, serious games, role play, participatory mapping, as in GIS mapping, design thinking, cultural theory, social multi-criteria evaluation, and participatory scenario planning. So if some of you know any of these methods, you might think, well, they have existed long before the idea of co-production existed, and that is true. So all of these methods can be done in different ways. To make them co-production again, the difference is that you really highlight the diversity of the participants, so make sure that they cover different thought styles, different perspectives. You ensure formats that enable discussion, so this kind of co-production that I mentioned. It's important to design a process that allows joint products, and in these settings, facilitation is extremely crucial. So you try to be neutral as much as that is possible, and you really try to not elevate any group over another. So we've been thinking as co-production methods as systems methods. And co-production methods, a lot of these methods are systems-based in one way or another. Many, at least, by acknowledging, the complexity of issues and the need for diverse knowledge. Some also by actually requiring some kind of systems mapping. So, for example, at IIASA we use a lot cultural theory, which is based on the idea that the world is, or social organization can always be viewed from 4 different archetypes. But as you can see, while this highlights really the diverse thinking, the rest of this approach is not so much specified in terms of how participation is organized. So it's only one aspect of systems analysis. Serious games, for example, enable this kind of language really well that we need for systems analysis and which Fabian has already mentioned. A rich picture is a really easy exercise that allows people to draw really a system, and helps them by using specific symbols like arrows and loops to highlight some of the systemic features. So they have very different levels of how they consider system thinking, as already explained by Fabian before. And participatory systems dynamics is the one method that really explicitly focus on the whole level of complexity of what system thinking can do by drawing causal loop diagrams. And while they look quite simple, they are really quite challenging to design, particularly in a participatory process. So they require a lot of guidance on the method, and if you want to make this co-production, at the same time you have to be careful to really allow for different views to come in and to not overrule, maybe ideas or change ideas when you integrate them into such a model. So it's actually quite tricky and quite elaborate. What we have done now in Fairstream is we took this, well, this is not it, this is an adapted version of a concept map of system thinking. So this highlights actually in a systems way the most important aspects of system thinking in order to give us a systematic reference to explore how different methods already consider system thinking, but also how we can provide easy tools to make it more explicit and help any co-production method to become more of a systems method. So I only will summarize this because it can take a while to go through it. It's less complicated than it looks. So for system thinking, it's extremely important to understand a system's purpose. And that is what co-production methods do by definition, right? They spend a lot of time in jointly defining problems and framing problems. And this links very much to point 10 on the top right. Understanding systems boundaries, which is extremely important in terms of distinguishing at what level are we discussing and operating, and where are the limits to what we can discuss and what we can provide solutions for. Then understanding system structure is about recognizing these interconnections, identifying and understanding feedback, understanding dynamic behavior. So what are the exact variables and stocks and flows? And also, how do we identify and understand nonlinear relationships? So I will leave it at these main aspects, maybe also highlighting that identifying leverage points is a big strength of system thinking, but also sort of difficult to arrive at because all of the other steps are sort of necessary to get there. So we have identified strengths and weaknesses of these co-production methods, and we found that, as I already highlighted, understanding a system's purpose and negotiating boundaries is probably their strong suit. Then a lot of them that have already included mapping ideas are really good at understanding system structure and also reducing complexity of some issues. The weaknesses in these methods is that it's very challenging to get to the point where you consider dynamic behavior, particularly if you work with non-experts, at differentiating stocks, flows, and variables, nonlinear relationships, and identifying leverage points, simply because it takes longer processes and more expertise in facilitation to arrive at this point, and simply also because individuals do not always have that kind of capacity to think that big. So you need to really help and guide them to get there. So we are producing some guidance on how to improve or analyze co-production methods from a system thinking perspective. So there's a direct way, as I hinted at, in including mapping tools and elements into the co-production process. And by mapping tools, again, I really mean simple things such as, tools that highlight how you make positive and negative connections with elements, how you think in a very explicit systems way about systems thinking. Also unraveling the kind of language Fabian mentioned, the specific systems analytical language of synergies and trade-offs and low-hanging fruit, etc., in a way that you really break them down into the elements and what they mean, and getting to the core of these kinds of ideas. And there's also indirect ways, and that means that you can analyze a co-production method or process with qualitative system tools. So if you record discussions, focus groups, interviews, etc., there's systems-based tools to analyze them. So to draw systems maps based on this information, for example. And on the right-hand side, you basically see that there's very simple steps to very extensive steps that one can take. That goes from adjusting the language or to including very simple mapping tools to including advanced mapping tools and identifying leverage points. And this is where we are at the moment in designing concrete guidance as to how to do that without changing a method, right? So we do not want to fundamentally just change any co-production methods, but we want to give them tools that that leverage really the opportunities of system thinking. And I'm looking very forward to presenting some results from our particular case that we have ongoing in India, and hopefully we get to apply elsewhere, where we're really producing this information together with stakeholders on the ground. And this is why it's difficult to present results before you actually are done with the process, because we are jointly actually even deciding the kind of methods that we use and the methods that are really most appropriate. Thank you for your attention.
Thank you so much, Suzanne, for a lovely, clear presentation. Don't leave us. We'll need you in the discussion. So colleagues, this, in conceptualizing and developing this session, we thought we'll have two leading presentations, one on systems analysis methodologies and one on systems thinking. And I did indicate to you earlier that the take-home message should be, provide you with evidence that this can be done. So we've had young researchers come across to IIASA, acquire these skills, and apply them to their research. So it gives me great pleasure to call researchers from IIASA, who are Korean citizens, to come and share their experiences of their research. And then in the discussion following their presentations, we would then see the integration between the methodologies discussed by Fabian, as well as the thinking expressed by Susanna, and see how these were incorporated into the research of our IIASA researchers. So let me firstly call Dr. Ji-Hoon Min, who's a research scholar in Energy, Climate, and Environment Program.
Hi, my name is Ji-Hoon Min. I work at IIASA at Energy, Climate, and Environment Program. Yeah, so adding to the conceptual discussion of what systems analysis is, I'd like to really show the specific example of what we have done in terms of this definition. And my title I put here today is Well-being, Energy, and Climate. So I will show how these can be related in this framework. Yeah, just excuse me for adding one more kind of definition of systems analysis here I found online. And that's coming from Handbook of Systems Analysis. And it's saying this systems analysis can contain a concept of social goals and equities, and also elements of judgments and taste, and also consideration of the larger context. So Fabian also mentioned the synergies of SDGs. So I will go back to this in a moment. And I will show how my research fits into these conditions there. So to tackle this triangle of well-being, climate, and energy, we started by defining what human needs in the first place and what basic needs are. So they start from, of course, your household service demands for obvious things like sanitation and clean water and cooking, space heating, refrigeration, etc. And in a wider context, in the community level, we all need like education services, transportation services, and like health hospitals. And even wider, at the country level, we all need certain infrastructural support supporting these basic needs, which can be like road network, electricity transmission lines, and like industrial infrastructure as well. And all these things in the end requires certain energy and materials. So our goal is to get there and quantify those needs. And now we have this categorization of basic needs, and then we try to come up with different thresholds defining what is decent life. So for different needs dimensions, we set up, for water, you need this much of liters of water per day to be decently clean. And for health, for education, we looked at the empirical data and see where like human development sort of saturates, and we set up that as a decent level of educational investment or health investment. So after setting up these thresholds, and what we could do was actually identify the gap between the satisfaction of this decent life and how far they are lagging behind these thresholds. So in different regions, 11 message regions in the world, with these colorful bars there, we identified, let's say, in Africa, there are more empty spaces here. So in Africa, most of the dimensions, the decent life is not met. But when you look at like Europe or Northern America, it's more full to the end. So they are quite leading a decent life. And we also try to aggregate all these dimensions. It's just all these different parts. So there was a challenge for aggregating these, but by just summing up nicely, we found like out of 1 to 0 scale. Obviously, more purple countries are there in Africa, and the Europe and Northern American are more white, so they're more decently living. So now we identify the size of the gap, and we try to link it to energy or emissions requirement. So then we go through this consumption-based accounting using the industrial ecological tool sets like MRIO, the multi-regional input-output matrix, or LCA, life cycle assessment database. So we can link the consumption at the household level to the upstream energy or emission footprint. So to get the fuller picture of the demand we need in the end. So then what we can get is this. This is showing the final energy levels for all 11 different regions. So different rectangles show different regions, and the biggest rectangle here is for the China region. And there are different color rectangles. So green lines show what they currently consume in terms of final energy, like annual average, so population average. And the black dot lines show the actual line for the decent living energy. So the energy requirement that's bringing everyone up to that decent threshold. So if you want to secure 100% population above this decent level, you just need this much energy, but now you're using this much. So that means even at the current level of energy consumption, you're still good enough for providing decent living for all. But that's not what we are seeing in the present. That means we are having the inequality challenge, of course. The distribution of final energy consumption is not equal. So at the bottom level, there are a lot of people in China region who are not meeting the decent life. And that's shown by these red dot lines here. So this red line is showing the final energy consumed for meeting the current status of decent life. So it's not getting to the black line, so it means we are not there. We are not making everyone a decent life. And another message we can see from here is, so that was China, and on the right side, the right one is Africa, South Asia, India and Pakistan, this area. You can see the green line and black lines are very close to each other. So considering the practical distribution of energy consumption, that means your average consumption is too close to the decent life provision energy. So that means unless you become really equal in this South Asian region, you cannot really practically meeting the decent life for all. And that means you really face different, like, unequal challenges in different regions, so that can also mean you need certain global redistribution to make it happen. So that was about energy, and that's the actually last slide for me. And now what we are making progress on is to link it to emissions level. So we talked about message model a lot today, and our research here is not at all linked to the IAM models. So now we try to link this research stream into message modeling effort and try to see how this increased energy demand for poverty eradication means in, like, carbon neutral scenarios in the future, like net zero or whatever climate scenarios. So by illustrating this example of research, I'm trying to say this work actually nicely shows the synergies of SDGs, yeah? By linking the poverty or hunger, like sanitation dimensions, together with climate change and energy challenges we have now. So that's the end of my presentation, and thanks.
Thank you very much. May I invite Zhang He, who's a research scholar in Advancing Systems Analysis Program at IIASA.
Hello, my name is Jung Hee Hyun, and I'm a research scholar in the Systemic Risk and Resilience Group in the Advanced Systems Analysis, or Advancing Systems Analysis Program. And I'll be presenting on my research experience, specifically focusing on resilience measurement for flood risk-prone communities. So I think this is a great example of how we can operationalize kind of systems analysis, research into the field work. And so the project that I'm affiliated with is called the Flood Resilience Alliance, and we focus on helping communities improve their ability to deal with the impacts of floods. And to do this, we advance knowledge, and we develop expertise, and we design strategies. And we focus on floods because floods affect more people globally than any other type of natural hazard. And this isn't new, of course. Response have, it's been done via disaster risk management, adaptation, but we take on a resilience approach. So this is how, yes. So why do we focus on resilience instead of relief and recovery, which are risk management approaches? It's because we find that $1 invested in prevention saves $5 in future losses. So instead of focusing on the pre or post-event risk reduction, we do the more pre-event. And this starts with measuring. So the FRMC tool, which I'll be introducing, is essentially the operationalizing of this concept. So why do we need to measure flood resilience? Measurement enables us to assess and demonstrate the on-the-ground impacts of improvement. So people need to identify what actually needs to be changed, and then once the change happens, measure if that was effective, and so that iterative process can happen more systematically. And then why do we need to develop our own framework? Because currently there is no empirically verified measurement framework for disaster resilience. So this is not new in that it's been done in the risk management, but new in that it's used as resilience. And how does this framework help us? It will contribute to the knowledge base on flood resilience, which in turn not only just affects flood resilience or flood risk reduction, but also increases social, political, and financial investment. So yeah, so it's obviously not just IIASA that can do this. It's with a huge consortium of various local partners in advocacy community programs. And so you can see we have, yes, various NGOs involved, other research institutions, but it's a holistic organization system. So this actually kind of points to how science to policy can actually come into play. And it's done in this type of format. And the reach is to various local communities all across the world. Right now we have about 269 communities that our research and our work is expanded into. And it's in its 10th year actually. So to kind of locate how this organization is actually done, so we have field workers and local project leads, so the local NGOs. And then from the kind of bottom-up information, we work, it's like, so we create the frameworks, the researchers on the desks, and then we kind of go to our local field workers, local project leads, and we ask them for their feedback, and then they'll go to the actual communities and get the data or the feedback in terms of if it's relevant or not, and then it's this continuous cycle of this science to policy. But so now the more scientific aspects of it. So we define resilience as the ability of a system, community, or society to pursue its social, ecological, and economic development and growth objectives while managing its disaster risk. And it happens in individual, household, small business, and community level. And then, of course, even up tiers. But when there is a flood event, if they are resilient, communities can essentially achieve their goals in their planned timeframes despite this external event. And so going back to the operationalizing this concept, we identified 44 sources of resilience. So based on the 44 resilience, we can identify and grade whether or not they are resilient. So they serve as proxies to measure how a community fares or how it performs after a flood. So, and these 44 sources of resilience were identified in various resilience lenses. So one of the lenses that we have is the 5 capitals. So I'm sure this is very familiar, but financial, natural, physical, social, human capitals. Another lens would be the 4 R's of resilience, which is robustness, redundancy, resourcefulness, and rapidity. And then there's also the disaster risk management cycles. So it's not just one way. So it has to take on a more holistic, but also, it's not just one, yeah. So, and then the way that we collect the data is also on multi-dimensional and multi-tier level. So it's household surveys, focus group discussions, key informant interviews, and secondary source data. So we have a triangulation of data sources. And then we measure it on a grading scale of A to D, and it's both quantitative and qualitative. So as I mentioned, we have the different resilience lenses that allows once, after the 44 sources of resilience are graded, then we can frame it with different lenses that allows the actual communities to understand their grading based on their preference of how they want to problem solve. So some communities better understand the information in the 5 capital systems or in the DRM cycle. So we have different ways of also kind of translating the information. And we found that the results allow for communities to essentially plan and design community interventions. And then through this kind of measuring framework, we continuously validate this via research. And then it also serves as a consistent monitoring and evaluation framework. And so it becomes an endogenous process. So essentially that is an iterative risk management approach and ultimately a transformative one as well. So this is also to kind of highlight how even designing interventions it's not a top-down approach. Through our measurement tool, it allows communities to kind of create their own they select their solutions, they develop the action plans through their kind of the survey results. And again, then we use the measuring tool to also assess the interventions themselves, and that allows for this endogenous process to continuously happen. So the kind of main takeaways that I would like to highlight is that the systems thinking, it happens and it can be operationalized with the concept of resilience. So it shifts paradigms of what constitutes risk management and what its social value should be by resilience measuring frameworks. And we aim to not only, like these intervention selections, we actually ask communities to kind of think about it in packages and portfolios, not just one. And it's because it's, again, like one solution will not fit all and that there needs to be multiple to create that kind of synergistic effect. So this is also a kind of shift in thinking. And we also have a naturally established participatory governance model, and it allows for co-production of knowledge and transformational outcomes. Yes, thank you very much.
Thanks very much. We have one last presentation. Unfortunately, Yona cannot join us physically. She's not well, but she's been kind enough to make a video recording to share with us. So while you watch the last video recording, we're going to go into a session of discussion which is interactive. So reflect on the kind of question you'd like to ask, because I usually just come up to you and ask you what's your question, so be prepared, okay? So can we have that video, please?
Good afternoon, I'm Yuna Kim. The title of my talk is Application of Integrated Assessment Modeling Systems to Air Quality Improvement in East Asia. Group in the Energy, Climate and Environment Program. Our program has been developed two flagship models, Message and Gains, for the integrated assessment of climate change and air pollution. We also supporting modeling communities by providing modeling resources as open source and organizing community workshops. PM Group also supports many member countries and international organizations by assessing issues and provide integrated solutions. I'm personally working with the GAINS model for a long time from my PhD study. GAINS is an integrated assessment model which can deal with air pollution issues and provide solutions in cost-effective way. As you can see in the figure, the problem begins with the human activity here, and then linked to emissions, and then control technology policies and atmospheric dispersion and health impacts in the platform. The GAINS also estimate cost of control and compare with the human health benefits to get a cost-effective solution. So it includes all sort of fields such as social science, public health, as well as physical science and engineering. One of my gains research is to develop national gains model. Gains Korea was developed with Konkuk University in year 2013 and has been operation through web server. To develop this model, domestic energy statistics and national emission inventory and other information were collected. It has 17 regions compared to 4 regions in other GAINS family models, such as GAINS Asia. Linking server GAINS model can make connected analysis possible, such as transboundary pollution. I did link to analysis using GAINS Korea and GAINS China by connecting national air quality policy scenarios together. 5 future scenarios were developed for Korea and China respectively. However, just use 3 scenarios for China to reduce complexity. 5 scenarios for Korea and by 3 scenarios for China can make up to 15 scenarios combinations. Base scenario is the weakest on, whereas BOTW ammonia reduction scenario that applied the most stringent controls. Here is the assessment of control policy impact by Korea-China linked scenario. These 15 bars showed PM2.5 concentration by each control scenario in the year 2030. Source base year PM2.5 is 26 microgram per cubic meter and the target concentration is 20. These 5 bar groups mean the effect of control scenarios of Korea, and these 3 bars of each group, the effect mean the effect from China's policy. So the leftmost bars of each bar group show the only Korea's control without China's effect. The rightmost bars here show the additional improvement from China's effect. As you can see, the Korea cannot meet the air quality target even with all the domestic control scenarios. But if China would do their maximum, we can achieve the target with just middle scenario of Korea. I would like to call it as the transboundary co-benefits from China to Korea. Let me move to the other issue, that secondary formation of fine particle. Left panel shows how VOC's emissions can form secondary organic aerosol in the atmosphere. Right panel shows the fine particle pollutions over Seoul metro area are mostly secondary aerosols, which account for 87%, and SOA is the largest contributors, which account for 34%. VOC is the lumped name of many volatile compounds and are very important precursors for SOA and ozone as well. The secondary formation potentials for VOC species are much different by species. Understanding not only amount of VOC's reduction, but their composition changes is very important to control VOC pollutant. However, implementing speciated VOCs in the policy IAM has not been tried so far. Here is the process diagram to implement speciated VOCs. In an out-of-GAINS model, I first developed VOC's emission-related activities by detail sector, then applied emission factors and control measures to estimate future scenario emissions in GAINS. Using the emissions by detail sector, we applied VOC speciation profiles to get the speciated VOC emissions. As shown in this slide, US EPA's database and many researchers were surveyed to generate raw speciation profile. Then they are lumped to the atmospheric chemistry scheme species to support air quality models. Speciated VOC emissions are shown in the right bar graph. Instead of using air quality modeling, we used the FAC method to estimate SOA emissions from speciated VOCs. Since aromatic VOCs are the most important group in the cities in Korea, we applied VOC control policies to emissions in Korea and check the aromatic VOC amount. As you can see here, the ban of solvent-based paint can reduce quite a few aromatic emissions than reduce SOA emissions. Yes, here is the summary. I'll not go over everything since you can read it from the slide. The points of my talk here today. Here are the first three. Systems analysis can give us much more comprehensive understanding, which also provides better solutions. Air pollution issues are an exception. The secondary, advanced scientific findings sometimes very useful to create better solutions, and the efforts of implementation of those science, they have to be continued. Here is some information about me. I started my university from journalism degree and got the engineering PhD degree at the end. I think IIASA should be the best workplace for the multidisciplinary person like me. Thank you for your time.
Thank you, and I know we're not live, but I'd like to just wish you a speedy recovery and making the efforts to actually get a message to us. So, colleagues, what we've witnessed, if I could get 3 chairs up there, please. Fabian, can I invite you, and Jang-hee and Jae-hoon? What you did see here, what we tried to demonstrate, was to look at the methodologies and the approaches for systems analysis and take our young researchers and show how they've applied this in a very systematic way to try and get an outcome. Now, you would have also noticed that there are incomplete answers as well because it's work in progress. There's no such thing as a stupid or a bad question. So please feel free to ask any question you want, whether it's for purpose of clarity, for purpose of better understanding, or for the actual research itself where you need to add or to find out something else. Any volunteers before I come to you? Oh, sorry.
You said anything. Okay. That encourages me. Yeah. Thank you very much for your presentation and talk. They were really interesting to me. I decided to start loopy thinking from now. It was a really interesting talk. I totally agree with that we should be able to provide useful information for decision makers. Also, there are lots of available information or data set, which means usable data set. So here's my question for you. Actually, we need to translate or convert those usable information into useful information. So I'm wondering if you have any general idea to translation or conversion. That's my question for you.
Okay. I'll give a short answer and I'll then hand over to Susanne because I think she has more to say about this. But I think from what we said, it should have become very clear
that what is considered useful depends on the user, which means that one of the first things that we need to do is to listen to them, what they want to hear. And you know, I have the impression that what we often confuse is data with information. We have huge data out there, and we think we just need to put it out there, and then somebody is just waiting for it to pick it up. But we need to process this. The term that you're using is quite adequate. It's translation. We need to translate it, but into which language we need to learn. So it's not that we think that we know the answer to it, but rather we need to first listen to what language we need to translate it into to make it useful. Susanna, do you want to add to this?
I think you answered this question very elaborately. And with co-production is one way of learning how to create information and to translate. So also, even if we have, you know, these sort of different processes these days of producing knowledge jointly, this doesn't mean that we know how to do so right away. So it still takes a great amount of humility also. You know, admitting that even if we already try to make things maybe simpler, that's not necessarily what it requires. So I think, yeah, Fabian was right. We need to listen and really try to understand that sometimes takes iterations too.
Thanks, Suzanne. I think there's an online question. Is there an online question? Okay, please come through here. Go ahead, Jay. You are muted.
Do you hear me now? Yes. Do you hear me now? Yeah, sorry. I just missed. Oh, okay, sorry. So I sent several questions. Thank you very much. Suzanne already answered on several of them, and more connected question. First question regarding software which are used for writing all these system models. Is it based on R? It's first question. And next question, in Central Asia, we have a lot of issues with water resources.
The title of my talk is Application of Integrated Assessment Modeling Systems to...
Sorry, Jay, there's some looping going on here.
Oh, sorry. Yeah, I just confused there. So, and connected question regarding the Central Asian region. So we have big issues with water resources, and at the same time, somehow we have some energy. And with climate changes, we have floods, we have more floods, and we have huge droughts. So peaks is going this way, like big and getting worse. At the same time, somehow our administrators and governments are addicted to build a huge dump with huge reservoirs. And we have huge evaporation. And now we have, I sent in the chat some programs from Switzerland. It calls Blue Peace, how works Switzerland on this problem. They built more small hydropower stations, which doesn't harm much nature. So we are missing proper decision-making tools to convince administrators, decision-makers that it will be reasonable to use something smaller, which doesn't harm much nature. It's one big issue. And another question, irrigation also needs this electricity. So maybe how to make all this balance, you know, just it's a very complex issue. I'm just thinking how we apply your tools for this complex issues in Central Asia and a lot of transboundary problems. So it's a very complex issue. I'm just thinking, is it possible to try to apply your system approach for this type of tasks? Thank you very much.
Fabian, do you want to take that?
I can actually also answer the first one.
Okay, go ahead.
So there's a variety of you know, software packages that people are using, ranging from simple Excel tools for drawing system diagrams. Susanna will probably say that the first thing that you need is a whiteboard, or you need sort of sticky notes. This is also part of the methodology. Python, GIS, whatever. I mean, there's a whole suite of tools, and of course, it depends very much on what the questions are, what that will determine the kind of tools that you're using and the kind of languages that you're programming languages that you're using. For the second point, there were really 3 questions, but I think they can all be answered together, in the sense that yes, of course, they can be, systems methodology can be applied, of course, also in the context of managing water resources. The trap that we shouldn't fall into is that we have already preconceived ideas of what the outcome should be. So I kind of sympathize with what you say about smaller dams, but maybe that's not the solution. Maybe the solution is outside the box. So we really need to think about the system first and think what is part of the system and what other options can we consider. When it comes to what you're describing, of course, is absolutely right. It's complex, and we need to take it apart. And I think Susanna has shown a great way of starting in this process by engaging stakeholders to raise, to collect the questions that are out there, to collect the issues, to collect the unintended consequences that we know from other processes, to avoid the pitfalls and to avoid these unintended consequences. Can be done. It's a lot of work, and I think we've shown you roughly the direction in which to think.
Thanks, Fabian. Yes, Suzanne?
What I would just like to add is that as too simple as it might sound for our scientific settings, oftentimes the big advantage of co-production settings and processes is to get people outside of the usual discussion environments and operating environments and bringing them together with, slightly different people that they maybe should be talking to, but usually don't have the time to talk to. And very, very often, simply doing that and enable discussion and not just, presenting solutions is extremely helpful. And I'm also not saying that that is the ultimate solution, but just creating new platforms that are hopefully less politically charged than other settings. This can be extremely helpful in exactly thinking outside the box, but also just, listening to different kind of solution spaces that the different actors and different stakeholders may present.
Thanks, Susan. I just want to focus on our IIASA researchers, Jang-hee and Ji-hoon. And this is not to cross-sector with the session later, which is your personal experiences. But I'm talking from a research perspective. When you were given a research project or you decide on something, what were you not told, one? And secondly, what were the big challenges that you faced? Thanks. If any.
The first question is what was not told?
Yeah, in the discussion of the research, sometimes there are pathways that you may not have envisaged, and suddenly they emerge as you go along. Do you find that? I'm just trying to prepare the younger students as to what can happen.
Oh, okay. I would say, from my experience at IIASA, it's not like typical disciplinary research institution. So you don't have a standard way of doing something. So you just explore whatever and come up with whatever possible way to do this. That's sort of what I'm learning by doing. So that's also a challenge, You are sort of forced to do something not used to yourself. Oh, what's the second question? Second question was what? Second.
Were there any difficulties?
Oh yeah. Okay. I think I answered. Yeah.
I think I would echo that experience very much so, in that I also, my personal experience is that I started off with my own postdoc agenda, and soon found out that that might be really difficult to do. But it was, learning by doing and recognizing that there is also limitations to your research agenda, but then also finding a way to then, find your role somewhere else, and that, the institute is big enough to kind of also host your skill sets and also foster your skill sets in different capacities and positions. So yeah.
Oh, thank you. I have a more sort of a general inquiry. The adaptation and mitigation interventions are dependent on how reliable the data are or is. And as far as today is concerned, we have heard from people who are working in Northeast Asia and large carbon producing, large emission countries here. Also, there are some which are under, sort of kind of going through poverty and stuff like that. So the data that is being produced from these countries are inconsistent. They're incomplete, including emission reports in the national GHG. So given that we have come a long way in terms of actually climate change reporting, inventory, all this stuff, and we have Kyoto, we have all that. Now we have Paris Agreement, but we are still very data poor. And they use different models in every country, and comparison of the results are very difficult. So as systems analysis and systems processes experts at IIASA, what are your thoughts? What should we do about these things? Is there a way that we can get around so that we can get that consistent, transparent data so that adaptation and mitigation interventions become more meaningful?
I think I can answer in brief. From my experience, especially being part of this large consortium research project where the data is actually sourced from the ground, I think that's possible and it's relevant because it's community-based. But when we're doing national agenda setting, like when we do our big, global modeling work, I think then it becomes an issue where we can't use reliable data sets. I think we're like different IIASA groups are trying to merge that gap with more citizen science data. I think, so data triangulation is something that I think is becoming more relevant, I guess, and needed.
If I may add to that, so I think there are various answers to your question. So at a high level, obviously we have to consider that no system is ever going to be perfect. And decision makers understand that. They constantly take decisions under uncertainty, and uncertainty also means that they may have poor data, and yet they need to decide, or they want to decide. And it's the process that decides at what point do we have enough data to make a decision, or at what point are you comfortable enough to make that decision. I mentioned in my presentation, maybe not very explicitly, a very interesting project that was started at IIASA, and that was this Fable calculator that addresses exactly that issue, that we want to have a global picture of the food, water, energy, land use, biodiversity nexus. So we want to have a comprehensive picture. At the same time, we want to be relevant for the local communities, which means that we need to use their data. Now, we're running into that problem all the time, that the data are inconsistent. They're using different methodologies and so on and so forth. And on top of that, not only do they use different methods and different data, but they may not want to share the relevant data, or they may not share the relevant methodologies. So the Fable Consortium has found really creative ways to deal with this problem that you have distributed knowledge that is imperfect, and yet you want to build a global system from it. And I mean, I don't know all the details about this, but this could be a starting point for your investigation of how this could be done in the setting that you're describing.
Thanks, Fabian. Any last comments from Suzanne? Yes, and Ji-Hyun. Suzanne, any last comment from you?
Yes, I think again it was well answered. I think we cannot just wait for the data to become better or perfect. I think we can do very well also in decision making with the data that we have.
I have one comment. I think that's the data challenge is always a fundamental challenge we have, and it also depends on which level of data you are dealing with. For citizens, the collected data will be very different from like emission inventory you were mentioning. So, I mean, I'm saying it's a fundamental issue, but IIASA is also trying to tackle whatever it can tackle. So Fabian mentioned Fable calculator, and in our energy community, we have also researchers, sort of informal community called EDITS, EDITS, and they are basically working on energy demand issues in different sectors. It's not just modelers, it's everywhere. But they also formed a data subgroup, and they try to standardize the way of sharing the energy demand data. It can be buildings data, transport data, and they try to follow as much as they can. So IIASA is trying to tackle this issue, of course, yeah.
Suzanne, Fabian, Jihoon, Yona, and Jangi, thank you very much for such lovely, clear presentations. Thanks to the audience for your questions. I'll take on the role of decision maker and close the session. Okay. Thank you.
Thank you.
Hi, everybody. Comes back. Always the break time is so short, you know. Well, especially who come from the overseas are so tired, you know. I'm not going to have 2 hours food. No, just 1 hour we can finish it. So you get your mind for what you're going to talk in condensed way. But it's best sessions. You know why? Because it's the last sessions. So you can have a break. Well, plus, the other reason for this best session is this is the main objective, maybe part of the main objective of the Korea IIASA conference in here. All the speakers has the experience in and out at the IIASAs. So we're working for the futures. With using your experience, how can we make better futures for the next ones? You know, I wish you talk for those kind of things, what's the right way to get the cooperation between Korea and IIASAs. You know that we have since 2008, almost 15 years connection between IIASA and Korea's. I was the founder of the Connect at the 2008. For that, I suggest NRF at Korea to funding start for IIASAs. But be honestly, what reason? So busy. Koreans are always so busy in here, you know. So one of the reasons we didn't do really tight, close together with the IIASAs, but this is time. When it's the young scholars from the IIASAs Korean side, so I think I'm so glad for you see you guys. So let's going back to that talks. Okay, that's my introductions. And first speaker is Gansen again. You're going to talk about the YSSP programs, right? And other things. Are you? I will do so, yes. Okay, go ahead, please. Thank you. Give me a big hands.
Thanks, Professor Moon. Let me just acknowledge Fabian as well, because we put this together. So one of the directives that was given to us was to try and provide information for students as well as emerging researchers from Korea about possibilities. So I normally speak about bacteria, fungi, and viruses, so I'm going to talk about something else here, and that's largely from a student perspective. So this CA is largely directed towards the students and to emerging researchers. So you would probably have seen this with the DG and also presented this, but I'm deliberately presenting it again because the research that's done at IIASA may be done in a global context, in a global approach, but often we try to relate it to a local context. And the word "local" has been used quite often to try and explain this working globally, but applying it locally, so it's in a global context. Now, you would have seen that the approaches that IIASA takes are very clear, very definitive. Fabian, as well as Suzanne, explained the methodologies just now. But I'm going to go largely to see if I'm a student and I'm looking into IIASA, what are the possibilities for me to do what I want to do? This is a membership map, and as Albert has pointed out, we have now this African footprint. I think the way you need to view membership is not the number of countries you have, but rather the number of laboratories that have become available to IIASA members to do their research. So if you're going to study energy, you could do it in India, you could do it in South Africa, you can do it in Brazil, you can do it in Mexico, you can do it in Europe. So by virtue of being a member of IIASA, it opens up a number of doors, what I would call access. Not just access to the sites, but access to the various models that have been developed by our researchers over time. So I think you are going into a situation whereby you have the necessary expertise and the tools, as well as the laboratories. I put the slide again deliberately just to remind our students again that this is largely the key areas that are currently in the IIASA strategy. And of course, these are all programs. There are very definitive parts to these programs. If you go onto the IIASA website, you will look at all the details in there. I put this deliberately again. I just disaggregate those papers. Often when you're a student and the whole focus is on where do I publish my research? How can I get a high impact factor, peer-reviewed article in a good journal? So while we are looking at this and saying, okay, fine, IIASA has got a track record which has grown exponentially even over the COVID period of production of high impact papers. And even more important is that the policy impacts of IIASA work has been shown to be significant. I'm showing this to you deliberately because my question is that, do you want to be part of this? Do you want to be in an area where you work with winners to produce outputs that are winning outputs? And if so, then what do you do about that? Just to also share with you that over time, IIASA was established in 1972. That's 50 years ago. The charter was written in 1972 and signed off. Casey and I worked on the charter, so 50 years later, the charter has been revised, and we will accept the revised charter in November of this year at the council meeting. But you can look here and you can see over time the number of persons that have had associations or had worked at IIASA who have landed up as Nobel Prize laureates. Now, I used to always wonder when I was a student, you know, what is a Nobel Prize laureate? What's it like to be a Nobel Prize laureate? And having met so many over time, they are just ordinary human beings doing extraordinary research or using extraordinary approaches to produce outputs that would not have happened had they not thought about their research differently. So the point I'm trying to build up is that IIASA is an environment that's a winning environment with the correct infrastructure, the right laboratories, the researchers with appropriate skill sets and who are really magnificent in their field, as well as the kinds of mentorship and teaching that they actually impart to their students. Now, I wanted us to remind us, especially for those students who have heard of IIASA for the first time, when I was first told about IIASA in 2008, I think, I asked, what's that? I didn't know what it stood for. I didn't know what it meant. I never heard of them before. And if you go to many parts of the world, people have not heard of IIASA. That's a reality. So Fabian and I thought that while we are in Korea, and because of the request by the NRF of Korea, we thought we'd use this opportunity to also interface with some of the universities to make them aware of available opportunities so that we reach a greater number of postgrad students, a greater number of emerging researchers. But this year was Korea University in 2008. That's when it first began, and then of course Prof. Lee and Prof. Sun in 2012. There was a joint development of research on the Mid-Latitude region. And of course today you saw some of the outputs of research in the Mid-Latitude region. I'm sure you might recognize some people there. Prof. Lee, I see you featuring as a centerpiece there. Now the question is, as a student or an emerging researcher, what you need to ask yourself, how do you strategically position yourself to become an established, internationally renowned researcher. Now, you can't read this in a book or something, but it's through talking to other people, years of experience, you try to apply these things to yourself. So where you enter is very important. It's like you want to get something done at the university. Who do you ask? Do you go to your lecturer? Do you go to your head of department? Do you go to the dean? Do you go to the registrar? Who's the decision maker? Who's the most influential? Who can actually help you with what you want? So identifying the best entry point is important. Do you want to go to IIASA? Do you want to go to PIC? Do you want to go to Korea University? Where should you enter to pursue that what you are passionate about? The second thing is networking. Now, if you're coming to a conference like this, and you haven't spoken to any of the speakers here, then you've actually missed an opportunity. There are excellent speakers here. There are excellent researchers amongst us. I've got Zig here. Zig has published over 150 papers. Go to him and ask him, what makes you tick? How come you are here where you are? How much of work did it take? Go to Prof. Lee and ask him, how did you build up this resilience group? The important part is that when you actually go into meetings where you can network, don't lose those opportunities as a student or an emerging researcher. Because that's where collaboration actually happens. That's where some professor might offer you a position and say, why don't you come as a postdoc in my lab? But if they don't know you, they're not going to do anything for you. So you'd see we very deliberately made all the name tags on a first name basis. There is no title to any of the name tags because we don't want anyone to be intimidated by titles and felt that there should be a free and open and easy exchange amongst all of us. Okay? So as you proceed into the future, remember, when you get to events like this, maximize the event. What we used to do is that we used to say, okay, fine, we're going to the American Society for Microbiology. These 4 people here we'd like to see. Now there's 4,000 people there attending, but you know which 4 people you want to see and why you want to see them. So you target, and you know what you want. And now it's so much easier. You know, they say it's often easier to choose a husband, wife, or life partner than a supervisor. Because a supervisor, if you don't choose the right supervisor, you can have hurdles along the way. So you have, Google search allows you to do the homework to find out who are the most productive researchers. You can get feedback from the students. So you need to network to do that. Timing. When is it that I should enter? If I want to do a PhD in air pollution, do I finish my degree at Konkuk University first, and then I will decide whether I want to go to IIASA? Should I go to IIASA now and have a joint supervisor at Konkuk and at IIASA? How do I position myself so that I can reach my goal quickly? Of course, this comes without saying. If you've got no passion, if you've got no commitment, if you've not got no thirst, no hunger, no enthusiasm for what you're doing, then you're in the wrong place. If you have any doubt about the research you're doing and you feel that you're in the wrong place, I would say leave if you can. Sorry. But if you applied your mind and thought about it carefully before you entered, it gives you a more favorable position to make a decision. Understanding pathways and opportunities. Often people want to go into pathways that have been proven, okay, fine, Professor X has done this work here, so here's a side path, let me try that. Often, it's important to choose pathways that have not been walked before, because that's when you'll find something different. The view from the bottom of a hill is different from the view from the top of the hill. So unless you are adventurous enough, you have an appetite for risk, then you would be able to take on those difficult research questions. It's okay if they don't work out, but when you conceptualize your research, you do it in such a way that you build emergency exits along your plan, so that if plan A doesn't work out, you can always transit to plan B. Now, Fabian used a very interesting word called immersion, okay? When he described it, I call it robust engagement at IIASA. So the point of the matter is that at IIASA, there are many ways that IIASA positions itself to assist you. Fabian had a discussion with me, and I like the word immersion, because the word immersion actually means deep mental involvement. So if you want to do systems analysis, and we talk about immersion, it's about you coming there and actually putting yourself in deep mental involvement in that knowledge field. And yesterday I was saying to Fabian, I said, I was wondering about the word immersion you used. And I saw it as a sponge. So a student is a sponge that's dry and can absorb anything. But the sponge will float until you push the sponge down. And then the sponge will absorb everything. You know? So sometimes diamonds are made under pressure, as you know. So often you take a student who's a self-starter, who can figure out their own way, or there are some that you have to help along. So the important part is that, you know, IIASA has various ways of enhancing capacity building. This is one of the ways. And any person can come there, not any person, but I mean you have to be eligible for an extended period of time. You can come there for 1 to 2 months to up to 2 years to be there as a researcher. Whether it's a research fellow, a research scholar, etc. You can have those conversations and those arrangements can be made. Korea as a member, as a national member organization, has the opportunity to have those conversations and get placement for their students. So what you will receive training on are tools and methods for systems analysis. I mean, Fabian described some of that just now. And the development of new tools. Now, the whole idea is to create a win-win ecosystem. So the student comes along, you have a supervisor, you may also have a joint supervisor at the university. The unintended consequence is that the research that you start doing could lead to further research between the supervisor, which of course gives out knowledge products. The key is that collaboration goes a long way in enhancing productivity. Then secondly, IIASA provides training for groups and teams. And this includes activities that enhance capacity for whole groups, including course on systems analysis, on IIASA modeling tools, on methodologies. Now, at this stage of the game, the idea that, that Fabian's unit does is largely to look at the area of work from an expansive point of view, the breadth of it. So it's not a deep dive into a particular area. As you proceed along and you choose a particular path, then of course it's a deep dive so that you sharpen your skills in that area so you can apply it to your research question. Of course, there are a number of models, and once again, Korea as a member of IIASA has access to these models. Most of them are open source models. There are some that are not, but you have access to these models. And if you want to know more about those models, I'm sure there are a number of researchers here that can give you the details. Some of you have already used these models, are using these models, or will use these models. Then, of course, IIASA, through CDAT, offers a module or course on project management. Because the management of a project is a very important component in the way you manage your time as well. And in the way you set yourself benchmarks of starting times and completion, and how does it fit in with the rest of your life and with everything else that you have to do. There's also courses on scientific proposal writing. I mean, as you saw the kind of journals that IIASA researchers publish in, there are modules that Fabian's unit runs online as well as in person on how to write and publish a scientific paper, whether it be in Nature or PNS or Lancet, etc. But the training that's required, how to write research grant proposals, okay? So these are basic stuff that a student or an emerging researcher needs in order to be successful. The more important part, I think, is this, you know, an academic climax is often, let's publish that paper in a great journal. But then you have to ask yourself, what is the point or value of that work if it stays in the journal and it's not translated into a public good, or it's not translated into an innovation or a product or a policy? So therefore you'd see that when you're applying for grants these days, a lot of the funders often ask you, what is the potential for innovation? What is the potential for translation? So I suppose in conceptualizing that research, you also apply that to yourself and say, okay, fine, what is would there be any value in this work? Okay, and it's about societal good, and more there's an emphasis on that. Science. In fact, IIASA is well renowned for its work on the translation of research to policy, okay, and across the world. One of the modules also includes teaching methods, how to teach effectively. So it's a very holistic offering in this part here where we provide training to groups and teams. Then, of course, we have researchers like you've had our researchers from Korea who are currently research scholars. There's also internal capacity building, especially of our emerging researcher cohort. And of course, once again, it is to sharpen their skills. It is to try and ensure that they have a holistic career development. So the take-home message for you is that there is a place called IIASA that offers all these capacity building initiatives, and you are welcome to access them through, of course, a conversation or contact or through your universities or research institutions. So, when I take the member organizations, we have 23 national member organizations and 1 regional member organization across the world. There are doctoral training programs. So, for example, Professor Wu, you could have your student who's doing a PhD come to IIASA and does a joint PhD with Zig and yourself as supervisors, and that student has their doctoral training there. The student may want to do a sandwich thing whereby the student comes there, does a section of work, produces a paper as one of their chapters in their thesis, and comes back. Those arrangements are all customized. It's on a case-by-case basis, depending on the arrangements, etc. But our researchers are quite open to that, and our researchers actually thrive on that in terms of mentoring and supervising students and getting the research output. So we encourage that a lot. And the beauty of it is that because our staff and researchers come from 52 different countries in the world, when you walk into IIASA, you have a different cultural experience as well. So it's not just about the academic part. It's other parts of development as well. There's also postdoctoral fellowships. Now, postdoctoral fellowships, we were trying over the years to try and get a set allocation for postdoctoral fellows. Now, not every country can afford postdoctoral fellows. But IIASA has an arrangement whereby, because Korea is a member, a national member organization, Korea can say to IIASA, look here, we'd like to reserve 3 places for postdocs next year at IIASA. We will fund them, and can you provide the necessary supervision or mentorship, and of course, the infrastructure. But this is a negotiated conversation that happens largely based on researchers' availability, their time, and of course, common interest. So there is the opportunity for postdoctoral fellowships. Then, of course, this teaching and training in systems analysis for, as I mentioned earlier, Fabian runs a lot of online courses, and these can be done either online or in person. He's already done quite a few across the world and continues to do so. It's part of the value proposition to member organizations. And then, of course, this career development for researchers in terms of, as I mentioned, scientific writing, etc. Currently, there's the postdoctoral opportunities. This is the IIASA postdoctoral fellowship program. Unfortunately, it's not as expansive as we'd like it to be, but it's something that's under discussion in the budget. So Casey, when you're at the council meeting, it's something that you should actually ask for, that the budget for postdocs should be increased, and because you could see the value of it, okay? Then, of course, this is an interesting one. The Peking University, they make available postdoctoral funds. But the good part about it is it's open to a student from anywhere in the world. It's not for Chinese students only. Okay? So, in case you thought it was not possible, here's 5 postdoctoral fellows from this country, from Korea, who've spent time at IIASA since 2017. Now, quite honestly, for me, and I'm saying this, it's not good enough. 2017 to 2022, we could only afford 1 postdoc per annum. What do we need to do to change that? We can either wait for it to happen or we can make it happen. It's a question of how badly we want it. If the universities in Korea say, okay, fine, Prof. Lee says, okay, the Resilience Center will reserve 4 postdoctoral fellowships for tenure at IIASA next year. We can have that conversation, we can make the arrangements, we can talk to the researchers, and if it is a mutually acceptable proposition, then there's always a possibility. But I get angry because to me, 1 a year is not good enough. And I'll explain to you just now why I don't think it's good enough. Because how are you going to change the next generation of systems analysts in Korea if we're having 1 postdoc going out a year? You know? We need to do something drastic. But what's nice is why I like this slide. It's a visual representation of what is possible. That when you have students here who want to go out, there's a possibility of them doing postdoc. Then, of course, we have these other programs in TWAS, as well as the European Union. These are other opportunities. These are the benefits of being an early career researcher at IIASA. And I've explained all the kinds of trainings that can take place and what are the possibilities. But I think it's belonging to that IIASA community and being able to have access. Now, I just want to quickly focus on the YSSP, the Young Scientist Summer Program. I had the privilege of serving on the council for some 14 years of IIASA. But when I first entered there, and they say they take 1 a year from South Africa, I said it's not good enough. So we, in consultation and in collaboration, and still making excellence and quality as the cornerstone of our decision making, created a program in South Africa where we took 50 students. Okay, and that went over 3 years. Then there was a funding for up to 9 years. And we now have a system center in Africa, in the sub-Saharan African region. I'm just mentioning this here because I mentioned it to the president of the NRF this morning as well, to say, if you want a game changer, then you need to do something drastic. I think what's important is that it's held annually from the 1st of June to 31st of August. Usually funding is available from the NMOs or RMOs, okay, depending. But quite often we run into challenges there, Fabian, in making sure we get funding. We said limited to 50 international students. Students should be in an advanced stage of the PhD, where they could actually come there, maybe complete the PhD as well. But I think what's important is that it's by application, it's stringent selection, and there's an expectation that there will be a knowledge product at the end of your stay, a journal article or a conference presentation. So, Park, you asked me to give you the details of the application process. I think the first thing you need to do if you want to be a YSSP, contact IIASA, see who your mentor should be, and have a discussion. Develop your research proposal in consultation with your mentor, and of course you complete and submit the online application form. Closing date, 12 January. It's actually open now. It opened on the 6th of October. If you go to the part there, you'll see that. And there were 7 doctoral students from Korea that have come to YSSP. From 2017, we've had 7. Okay? Some of you are in the room here, so you can identify yourselves. So what here seems impossible is always possible. All right? What I would like to say is that if you want any information about IIASA, please join IIASA Connect. Cherry Edwards, who's in the room here, you can ask her. She will put you in contact with Monica Bauer, who will sign you up immediately. They're at work at the moment in Vienna, in Luxembourg. And you can immediately sign up to get any information that you want. If you have any questions, you can post a question on IIASA Connect. You will get a response. Okay? At the moment, these are the number of people across the world who are on IIASA Connect. So, if you need further information, those are the things. But I think to end, and thank you, Chair, for allowing me the privilege of doing this, let me give you a flavor of what the YSSP is by just showing you a video of our last intake. So if I can just have the video of that YSSP, you'll get a feel that it's not just about academics, but it's holistic. Thank you very much.
Ganson, Can you back to show the slides for the YSSP? The few slides back. One more. Yeah. Oh, no, next one. Next. You talk about the, yeah, right. Just please leave on there. Well, somebody wants to talk about this for a little bit more.
Yeah, I just want to show the video quickly.
Oh, I see. Okay, go ahead.
The YSSP is a 3-month mentored research program. It's aimed for students in their last years of their PhD program, and they come and work with the IIASA scientists on a agreed-upon project that is typically one of the chapters of their dissertation, and they get a chance to really do mentored and independent research while they're here.
It's been really special to come here and really get a lot of attention put on my project and my work, and help from famous scientists. It's been super cool.
At IIASA, one of the biggest benefit I got was the collaborative environment and also how different departments talk with each other. From a research standpoint, how approachable the researchers are kind of makes it easy for me to quickly get stuff done.
It's just fascinating people who research quite different things, but then come together and talk and exchange on these things. And I think that is really mutually beneficial for everyone involved here.
The human perspective is just fun. It's very intense, so be prepared.
We're taking candidates up to the mountains and also show them Vienna. We're organizing tours to really get them to familiarize themselves with the country, to get lots of chances to get to know each other, to bond, and to get in touch with staff.
The people here are so kind and so nice. They're just so willing to sit down with you and share their insights and troubleshoot or even just chat about life.
The castle here is a pretty cool research environment, so it really allows you to escape all the chaos around you and focus on your work and on your research.
You should apply to the YSSP if you're interested in getting excellent academic mentorship and really great exchange with PhD students from multiple disciplines and all over the world.
You will meet a lot of new people that do similar things to you, and that can be a very useful way to start collaboration or even just learn something.
It's affordable, it's fun, and plenty to do.
Do great science and have ice cream breaks in between.
Thank you, Ganson. It's an excellent talk. Fabian, you want to add something about the IIASA? You have any ads? No, that's enough. Well, let me give you the microphone to Mr. Park at the NRF. He has some kind of talk about the YSSP. Go ahead, Mr. Park.
Okay, thank you, Dr. Gansen, for your explanation about the program. So let me take a few minutes to explain about the upcoming calls of YSSP and postdoctoral program on our side. So please forgive me for speaking in Korean just for a few minutes for me to better explain for our Korean guest. Okay. 안녕하세요. 저는 그 한국연구재단 국제교류팀 박성빈 연구원입니다. 일단 지금 프로그램 얘기가 나와서 잠깐 저희 내년에 나오는 콜 조금 설명드리려고 잠깐 좀 마이크를 빌렸는데요. 일단은 앞서 지금 설명해 주신 YSSP 프로그램은 대학원생분들, 박사과정생 대상으로 저희가 3개월 동안 IIASA에서 연수받을 수 있는 기회를 이렇게 드리는 건데요. 여기 오늘 알룸나이들 이렇게 분들 모셨는데 들어본 결과 굉장히 좋은 기회라고 합니다. 그래서 이제 저희가 23년도 YSSP 콜이 지금 아까 말씀드린 대로 오픈을 했어요. 그래서 내년 1월 12일까지 오픈이 돼 있고 조만간 재단 통해서 전국 대학으로 아마 홍보문이 나갈 겁니다. 그래서 여기 계신 대학원생분들 또 만약에 이제 교수님들 계시다면은 그 제자분들에게 적극적으로 홍보해 주시면 감사드리겠고요. 두 번째는 박사후 포스트닥터럴 프로그램이 이제 저희가 경연으로 2명씩 뽑고 있습니다. 그래서 이제 지금 현정희 박사님께서 이제 박사후 하시다가 이하사로 이제 정규 직원으로 채용이 되셨는데 이제 내년에 또 그 박사후 연구원을 뽑고 있습니다. 그래서 아마 이거 콜은 한 2월 정도에서 아마 3, 4월에 저희가 어플리케이션을 받고 7월부터 연수를 개시할 수 있는 프로그램이에요. 그래서 이제 2년 동안 연 4천만 원에 해서 지원을 하고 있는데 이것도 지금 보면은 제가 이 사업을 한 3년째 맡고 있는데 YSSP 하셨던 분들이 포스닥 하셨던 분들이 국내에 와서 이제 연구를 하시는 분들도 계시지만 이하사에서 이제 채용이 되셔서 직접 연구를 하시는 케이스도 많이 있습니다. 그래서 좀 국제 기구에 대해 관심이 있으시고 그런 기회에 관심이 있으시면은 이 기회를 빌어서 좀 적극적으로 참여해 주시면 감사하겠고요. 만약에 이 프로그램 관련해서 질문 있으시면 저한테 연락을 주십사 하는데 제가 지금 이게 제 연락처가 없어가지고 나중에 이제 프로그램 끝나고 저한테 와서 오시면 제가 명함을 드릴 테니 하고 아마 이제 이거는 이제 각 대학으로 아무튼 홍보문이 나갈 거니까 좀 유념하시고 지켜보시다가 지원해 주셨으면 좋겠습니다. 감사합니다.
Thank you, Songbin. Well, it's not much to secrets, don't worry about that. If I translate that, he talk about the Jensen said that, so he said, he said that they're going to be open for the 3 months for the YSSP, and he talked about the doctoral position too, for postdoc positions. So please for that. Yes, go ahead. Any questions?
Not a question actually, but a comment maybe.
Yes, please.
Can you?
It's not working.
Oh, it's working now. Sorry, I'm screaming too loud. I just wanted to add maybe to the presentations that Gansen made and Fabian about YSSP and what you have heard here, because all the programs and research groups are preparing also slowly for that, thinking about specific areas that we would benefit and we would be ready to work. I mean, we're ready to work. We are open, of course, for good ideas. But there are certain areas that we actually are already working on and would benefit from having help or fresh mind joining us in a number of endeavors. So please look at the program and research group and program websites, not only on the standard default website of the YSSP. I don't know if this is connected, but we had a discussion just last week, for example, and there's an exchange of emails going on, trying to formulate a couple of questions or topics that we would like to have someone addressing them. If you happen to work on this area, the chances are higher simply, because we have someone that is waiting for you there to work with you. While the other areas maybe we simply will not be able to support someone because we have no capacity. So this is something that is important to observe, and I think all groups and programs are trying to do better. So, apologies. So it's something that it's our responsibility to actually improve on that, and we're trying to do that. Thank you.
Thank you very much for kinder introductions for this. Okay, please, who designated the experience for the IIASA wants come to the front, please. Also, who are listening online or online or in here? If you have any questions, but it's hesitate speaking in English, please go ahead and ask in Korean so we can translate that. For question only. Well, this, as I mentioned already, this is very free sessions. We like to share our experience for the future, next generations. So if you can ask questions for the IIASA, or you can talk about your experience, or anything you want to talk in here. Please go ahead, but I like to speak who didn't speak in front, last sessions, first. Okay, go ahead. Then name your organization and if you have any places, and name and ask comments.
Thank you so much. Okay. I grabbed the first mic because I'm the oldest man among these. I am Munil Kim, is an assistant professor at the Department of ICT Integrated Environment, Pyeongtaek University. The city of Pyeongtaek is located south of Seoul. It could be considered one of the safest cities in the world because there are 2 U.S. Army bases. In addition, it is noted for its nice harbor and Samsung's semiconductor plant. I think this plant is the world's best plant because they gave me a good research fund. And I would like to thank to Fabian because he gave me this nice badge. I am also a guest scholar at IIASA currently. I have co-worked with IIASA over maybe 7 years in the area of climate change, forest and governance, land use and forest inventory, and MRV process as YSSPer or guest researcher or postdoc fellow. Based on this research, I had published more than 10 SCI papers as main or one of co-authors. Thanks again for inviting me this anniversary conference. It is great honor that I am together at this meaningful time and expensive place. And one more thing, it's very important things. Currently, I am in poor shape because I am suffering from the shingles. In Korean, it's called 대상포진. But don't worry, it is not an infectious disease. So I can touch you, you can touch me if you don't mind. Anyway, I took drug to overcome it. One problem is this drug tended to cause sleep. So please forgive me if I begin to yawn widely or even to nod. Yes, thank you so much.
Thank you, Professor Kim. If you were near him, it's too late. You know, I was here in this room all the day without any masks. So thank you very much for your experiences for talk about that. How long you've been there, by the way, the IIASA?
Maybe I was 2014 is the first time to go to the YSSP student. And after 1 year, 2015, I came back to IIASA as a guest researcher for co-working project. And then after my PhD, 2080, I came back to IIASA again as the postdoc researcher funded by a National Research Foundation. And 2012, finally, I got a job in South Korea. So yeah, that's why I am here. Yeah, alumni,
Wow.
one of alumni.
He has all experience of the IIASA. IIASA is his motherland, actually.
Yeah, exactly. Yeah.
Okay, pass the mic to the other person, please.
Yeah.
Thank you.
Okay, hello. My name is Chaoro Song. I'm now a research professor in Korea University. Before I start sharing my story, I really thanks to the NRF first, because what I remember that I got a fund from the DEADE, from the German fund, and then I can study in the Germany, especially in the Berlin. And then at that time, my supervisor was former YS peers. And her name is Sabine Fuss. Maybe everyone know that. So based on her recommend, and then I applied the IIASA YSP in 2017. And then the problem was I was the only student from the Korea at the time. So it is quite hard, it's quite tough to get used to it, to the European life, but I made it anyway. So Thankfully, I also can study biogeochemistry modeling, BGC-MEN model, and IIASA at that time. And then I still quite a bit closely work with the IIASA research staff in the biodiversity and research group. So at that time, what I remember that is many IIASA staff really work hard and then made the good comments that guide me to do my work better. And then based on that, now I'm still researching the biogeochemistry things, so that are really good experience, and then that made a big motivation to me. Yeah, thank you very much. Yeah.
Thank you, Professor Song. So far, last two persons just only talk for the good things, you know. But I wish if you have any things, you know, you can talk for the other things too, for that. Okay, go ahead, pass to the microphone to any volunteers.
I have nothing to say about bad things for you.
I'm not saying bad things, negative things.
Anyway, thanks for having me today. I'm so glad to be here. And before starting, I would like to give a special thanks to Professor Lee, who gave me a chance to participate YSSP. 감사합니다, 교수님. And I'm Young Choi, who I was raised by Korea University as a researcher, and now I'm working for Green Technology Center, which is a government research center. We support national strategies in technology field, mainly to deal with climate change. And currently, I am in charge of two projects. First one is about the assessment program of carbon neutrality according to the introduction of renewable energy at local government level. And the second project is about the biodiversity assessment model by using big data and spatial modeling. So if anyone has interest in this project, please feel free to find me and contact me after these sessions. And I joined IIASA in the summer of 2019. I joined the Ecosystem Services Management Group, which is now PNR Group. And I conducted a research with many graded senior researchers, and I got so many things from the experience at IIASA. I not only gained the knowledge, I also expanded my research interest and my vision. And of course, the good memories in Vienna with friendship with good researchers from all over the world. So I'm so honored to be here as a YSPer. Thank you for everybody. Thank you.
Thank you. Go ahead.
Hi, my name is Eun-bin Park, under the supervision of Professor Oh-Gyun Lee in Korea University. I am PhD candidate, and I was participated in YSSP 2021. Because of the COVID-19, I didn't go to Luxembourg, but with a great virtual, a lot of programs, it was great experience to improving the research skills and understanding other research. During the program, I assessed effect of afforestation options, especially focused on carbon storage with special explicit model G4M in North Korea, with co-supervision of Dr. Andrei Krasovsky and Dr. Florian Kraxner of PNR Group. Also, as you know, I cannot assess the North Korea data set. We had to rely on remote sensing data and global static data. But our lab has already experience of North Korea forest modeling, other models. I refer their studies. Also, although I participated in virtual, there were other opportunities to visit IIASA for me. As Professor Ugin Lee said, in this year, we visited IIASA for the IIASA KU workshop in May and shared our research topic. Also, we participated EGU sometimes. Therefore, I think the continuous collaboration, IIASA and South Korea, is essential for a young generation student. Thank you.
Thank you.
Okay, hello, I'm Hyunwoo Jo, a PhD candidate under the supervision of Professor Lee. Briefly introducing myself, my research interest includes application of deep learning and remote sensing on the domain of agriculture and forestry. And as Dr. Andre kindly introduced at the previous session, my project at the YSSP period was optimization of the forest fire model, FLAM, of IIASA, and optimize it to the environment of South Korea. In addition, thanks to Professor Lee giving me a lot of opportunity, I have participated 2 consecutive Horizon 2020 projects for 5 years. And at those projects, I researched on deep learning-based agriculture monitoring. So that makes me to work with European countries at the very start of my degree, which was very fortunate for me and good for me. And I want to continue cooperation with Europe, especially with IIASA. Thank you.
Go ahead.
Hello, my name is Jin-Seok Kim. A PhD candidate groups, whose groups, my research interested in emission modeling and emission inventory and air quality modeling. At IIASA, I worked as a guest researcher in 2020. I worked using gains and create inventory scenario processing, emission processing, and quality modeling to the great. I'm sorry. Emission. Gains create projects which Gongun University and IIASA collaborated. I have researched the nonlinear source receptor relationship for the speciation of VOCs and secondary pollutants, and I have been worked on the precursor information and transfer impact relationship. Although it was a short period, I was full of anticipation to work in a new environment and a prestigious international organization. However, I was worried about my lack of English skill, but despite my lack of English skills, I was able to comfortably conduct the research with the kind responses of the people I worked with at IIASA. Thank you.
Hi, my name is Minho Park, and I also in Woo's group in Konkuk University, and my research interest is about the emission processing and modeling and air quality modeling things. And I was 2022 YSSP with Joe, and so I would like to say, I would like to appreciate to my Home Institute advisor, Prof. Wu, to give me this nice opportunity, and also say thanks, very big thankful about my two great supervisors, Jake and Yunha, to give great insight of my topic and the daily life of my in IIASA. So I want to say more casual things than others. So I can easily say the YSSP period is my most memorable experiences in my whole life, because I have a very strong Luxembourg syndrome now. So not only do research with the high-level researchers in IIASA, but also I can make very good friends in there with very nice YSSP colleagues and other researchers and staff. They always want to help me to feel more easy and comfortable, and want to give. They don't hesitate to give good feedbacks and comments about my research and everything. So I got very big confidence then when the program started. So now I found very nice friends, Joe and other countries' friends. We still have a good relationship, and we still have the group chat, and we want to see each other in like other conferences like AGU. We hope, but I don't know. So yeah, so I want to say encourage to like other scientists, young scientists who didn't apply YSSP yet. It is very good opportunity, and it would be very good experience to improve your everything, like research potential and like mentality to, I can do that, or I have not very well, I don't have very well English skill, but yeah, I did it. I made it. So you also can do it. So yeah, it was very good, and this is done. Thank you.
Thank you. Well, the Hyun, Dr. Hyun, right? You already, you, okay. Well, who has already experienced, the more than alumni who has you talk already your research papers last sessions, I want you to speak out for the next generation, what you have to prepare to come to IIASA's, those kind of things, to be an advisor things, Also, things you never expected something in there, the surprise of things, those kind of things. Well, last two people, but you go ahead. You speak one you want. But who has Dr. Min and Hyun wants you to talk about those kind of things, next down, okay? You speak. Go ahead. Go ahead.
Yeah. My name is Yu Jung Chang. I'm a PhD candidate at Konkuk University. My main research interests are improving emissions inventories and air quality policy controls. I participated in 2021 YSSP. During the YSSP period, I had improved VOCs emissions in Northeast Asia using Gaines framework. YSSP is very big opportunity for students, and it was very challenging to me. Despite the help of many people and Professor Wu, I had a lot of difficulties in conducting research by myself. However, I
participated in the YSSP, I felt that I was a little bit closer to the goal, become a good researcher. One disappointing is that 2021 YSP was conducted virtual because of COVID-19. If it wasn't for virtual, I would have gained more experience with in-person. Still, it was enough time for me to check my own growth just by participating in YSSP. A year ago, I was in a rush to do only what was given to me, but now I think my vision has widened a little. Thank you.
Thank you. Right. You first,
Yes, I
Jung-hee?
can
Go
go.
ahead.
Yes. So again, my name is Jung-hee, and I'm not sure if I'm speaking to the crowd that I do wish this message would come across, in the sense that I think this group is very opportune in that you already have established connections to IIASA, but I also think if you have colleagues in other universities or other research groups who don't have direct contacts or relevant projects, seemingly, you can still contact various researchers at IIASA to identify a sweet spot, like Zig said. I think even on our IIASA website, we don't have all the projects that are going on. Like, new projects are always coming in. And so there might be opportunities that is not publicly available that you might be able to access if you just get into contact. So I would encourage, just sending a cold email and, reaching out, asking for ideas of who you might want to have research collaborations with. And yeah, I think that would be my best advice, is just being kind of not shy in sending out cold emails and contacting your outside of your network.
Thank you. June?
So it was about the general advice I can give to
Yeah, right.
the
Yes, please. I think that will be more valuable then.
So I believe to work in situations, in circumstances like IIASA, what you need is some kind of broader perspective, regionally or in topical ways. But from my experience, I of course grew up in Korea, and I did also graduate studies in Korea. And what I feel is, for graduate students, your focus is somehow constrained by your professors' like funding situation or whatever realistic limitations, and that in many cases is focused on the local context very specifically, the impacts of local policies or but at IIASA, if you want to contribute to the higher level of research and more impactful findings, I'm not downplaying the strength of all these people, and the very specific local knowledge is of course important, but you need to sometimes try to think about how my work is related to the broader context.
Thank you, Jung. You want to add anything for the Jung-hee? Okay, go ahead.
Sorry. Maybe I have to something to the next generation for encouraging the YSSP student. Okay, this is a very small episode. Among 2014 YSSP student, there was some YSS per couples. I was not that time. I already married. Anyway, the most of them were broken after YSSP period. It was sad, but it was a real. However, one couple survived more than 5 years after 2014. The man name is Pietro from Italy. He studied at Sweden. He is my wonderful best friend because I helped him about GIS technique for his research during YSSP period. And then my name was involved in his nice two papers. Their impact factor over 6. After that, in my brain and heart, he was be my best friend maybe until to my dying day. Thanks, Pietro, again. You made me to be a professor. Thank you. Thank you again. One name is Jie from China. She studied at USA. I met them again 2018 AGU in USA. They told me that they have a plan for wedding. Now they got married and have a baby. They are good reason that we should work together for the future generation. It's a really amazing event, yeah. I would like to say one the famous sentence. I really like it. Stand on the shoulders of giants. Isaac Newton said. In Korean, 거인의 어깨에 올라서서 더 넓은 세상을 바라보라. It is main sentence in the first web page of Google Scholar. For me, the first giant is my dear supervisor, Professor Lee, and the second giant is IIASA. Frankly, every experience at IIASA in my life was good for my progress toward being an independent researcher. The most valuable thing which I learned from IIASA is the endless passion and effort for working together to solve the important problems for a sustainable world. In the morning session, many professional scientists said the integrated research and work together with different research fields is difficult or inconvenient. In my site, IIASA scientists know well their mission and they love their mission and research. Based on it, I have tried to love my research life more. It's really good influence on my life. I know my words are quite abstract. However, I am sure that you feel the same thing if you may one day work at IIASA. Thank you.
Well, if I remember well, you're Professor Song, right? Professor Kim. Well, what he said, the Albert, you just missed that. He said the IIASA, his motherland more than that, you know. The same quality of their, you know, just the gods, whatever. So whatever he done in here, it's all the benefit of the IIASA, you know. Let's give you one more hand, big hands for him for that. Okay, anybody wants to add more? Anything? Yes, you want?
IIASA does not award degrees.
Yeah, I know.
So we have no graduation caps, but I do have some caps for him here.
For him? Wow.
Thank you so much. Wow.
Wow. Well, while he distributing the caps, you know, most of the Koreans kind of very shy to go abroad and talk with stranger peoples, you know. It's or even the streets, they not talk much with the stranger peoples, but they are all very brave Koreans. Well, that's IIASA gave the opportunity for them to be more brave for this. I'm very sure for that. Thanks.
Can we have a photograph of the caps on?
Later on. Let me finish this session first, okay? Okay, anybody wants to add more? Well, you got a gift, you have to talk more. That's, you know, nothing free. Okay.
I can add that I
Okay,
think
go ahead.
something that, like in the spirit of graduation cap, I think I would actually kind of compare IIASA as a very, they're very easy to transition from, I think, a university degree because the kind of camaraderie and colleagueship is definitely there. It's not just like a work environment where we just do 9 to 5. I think everyone enjoys each other's company. We're also very flexible in kind of transitioning different research like topics. I had this great opportunity to start a new project thanks to a strategic initiative in a topic area that I've never done before. So I think even as a postgrad where we're so siloed and become esoteric in our nature of higher academia, we're still we have the opportunities to kind of be taken out of that space and explore new fields and to collaborate with new colleagues. So I think that's another big highlight of kind of doing the postgraduate fellowship and young researcher at IIASA.
Good. Well. Oh, he's professor.
Yeah. Okay. So actually,
I think he stayed more than any other papers at the IIASA, maybe much longer than Albert stays, maybe more than almost a decade, in and out continuously. Go ahead, Professor.
Kim is 10 years, and then in my case, maybe 5 years, 6 years, yeah.
See, longer than you, eh?
Okay. So anyway, actually, I mean, I prepared with my colleagues, and then and also with the IIASA colleague for this wonderful event. So what I felt, and actually quite a bit surprised thing is that I think this is the first time that whole Korean alumni tied up. So I think, as I remember that in my experience, it's the first time. So I think there were the other alumni in Korea, as I know that. So maybe next time, maybe it'll be good to the other alumni who cannot participate today will be hopefully all gathering together, and then that will be wonderful. That keep making our network in Korea, and as well as studying more with the IIASA together. It will be very, very nice, I think. So maybe, hopefully, IIASA, maybe, I think IIASA can support some point to gather up in the Vienna or some other conferences in the Europe or America, maybe. And also, I think NRF or the other also can participate at this kinds of event, I think. So maybe it will be very good to support us, please.
Okay.
That will be good for us, I think.
Okay.
Yeah.
Thank you, Professor Kim Moon-il Kim, right?
I mean,
yeah. Right.
Yeah.
Well, I'll pass the same words to NRF in Korea to support some kind of, IIASA Korea alumni who is in here. So that's good suggestions, but please keep in mind from the IIASA person too, okay? Thank you, good for the suggestions. Any other has more suggestions, any talk? Okay. Well, I think it is about, thank you very much. Yeah, why don't you everybody get the heads on the head and take pictures? Please, Me? I'm too old. I'm too old for that. Okay.
I have all of you captured.
Thank you.
Well, I was planning to shorting a little bit, shorter than actually we designated for this because everybody's so tired, especially from the overseas. You know what? They give me 20 minutes to remark for this last closing sessions, but I'll do it in 2 minutes. Okay. Well, last almost 15 years relationships between Korean NMO and IIASAs. But this is I participate all the conference in Korea, but this is the largest one in my memories in here. Also special thanks for who coming from the IIASA headquarters, especially the Alberts and Kansas and all other persons give a talk for this. Really thanks for that. Also, who organized Professor Lee from Korea University and Professor Wu from Konkuk Universities. They spent hell of time for this. But I'm not forgetting to thanks for the NRF for Mr. Choi for this organizing whole things, you know. Well, the last year, I'd like to thanks for the who participate, all the, you know, students and alumni in here. I hope this is kind of first new step for going for the next ones, you know. The suggestions they talked one, I'll get together, I'll talk to, and then I have to doing better ones for next years if you can have these kind of opportunities for that. Well, thank you very much and have a good night. You want to say something, Albert, for the closings? No? Okay, go ahead. No, but you're the boss, you know. Okay, let's hear from you.
Thank you very much. And from my side, I'd also like to thank everybody involved that put together this wonderful get-together. It was good for us to see all of you again. And I hope this is the first of many more gatherings in the future. I also want to, at the same time, say thank you to our staff from IIASA that have traveled all the way here. Zeke and Fabian and all the other people that have spoken earlier today. Please, thank you very much for those contributions. But the key thing at the end of the day is the research that we want to do together moving forward. So I hope that we'll find a way, we'll find some avenues to bring the researchers together to explore their favorite topics around the area of systems analysis. And we look forward to also hosting any of you that come past Luxembourg. Remember that you, once you're part of the IIASA family, you're always part of the IIASA family. And please look us up when you go past in that direction. And we look forward to seeing you in Austria should the opportunity arise. So thank you, all of you.
Thank you. I forgot one thing for the thanks. Who is participating on online, you know, right? Whoever they're listening or hearing, watching us for this participating online, thank you very much. I can see you, but you can see me, you know, so really thanks for that. Okay, good night.